Hello and welcome to this introductory course on React Native. You probably use apps every day, and if you're taking this course, you likely know that some of those were built using React Native. Even if this is a completely new topic to you, don't worry. That's why you're here, right? You're here to learn to apply your coding skills to the world of mobile app development, and this course will help you get there. To help you better understand the applications for the concepts that you'll learn about, you'll explore this course from the perspective of a developer who has been tasked with creating a mobile app for a client. The client is Little Lemon, a Mediterranean restaurant that specializes in simple food and casual cocktails served in a casual environment. Let's find out what knowledge you'll gain to make this app happen. You will start off by learning about what React Native is, its benefits and use cases. You will then learn about the basic components in React Native, styling the components, and using them to build a React Native app. Next, you will move on to the core components of React Native, such as view, text, and scroll view. These primarily concern setting up the visual layout of your app. In the next module, you will learn about the rendering of large lists within your mobile app and inputting text via the keyboard. You will learn how to build large and performant lists with both flat list and section list components. And you will learn how to configure user inputs via keyboard using the text input component. The next module is about creating pressable components, rendering images, and using React Native hooks. This includes learning to build buttons and other pressable areas to add interactivity to your apps, as well as learning how to display and style images in an app. And you will become familiar with some common React Native hooks which can extend the functionality of your React components. In the module that follows, you will learn about navigating between screens using React Native navigation. You will learn different types of navigation, such as stack, tab, and drawer navigation, which are widely used in mobile apps. You will also become familiar with the core features of React navigation, and by the end of this module, you will be able to set up your app with React navigation and move between screens. The final part of the course is about the graded assessment. For this assessment, you will create a Little Lemon newsletter sign-up form in React Native, and you'll get an opportunity to provide feedback on your classmates' projects as well, since this is a peer-reviewed assignment. There are many videos in the course that will gradually guide you toward your goal of becoming a developer. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then consolidate your knowledge by consulting the course readings and putting your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. And remember, you're not alone in considering a career as a mobile developer, which is why you'll also work with course discussion prompts that help you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and grow a network of contacts in the web development world. You have probably encountered a few new words and technical terms in this video. Don't worry if you don't fully understand all these terms right now. Everything will become clearer soon. After all, this is part of the reason why you are taking this course. In this course, you will build a cross-platform mobile app for Little Lemon, a family-owned Mediterranean restaurant based in Chicago. You will use React Native to build Little Lemon's mobile app. Customers can use this app to learn more about Little Lemon, their menu, and contact the owners. In this journey, you will learn the basics of React Native and use that to build the restaurant's mobile app. Adrian, one of the co-owners of Little Lemon, wants a mobile app for the restaurant. He would like you to work on this project, and you just heard about React Native and its benefits. But you want to make sure it is the right tool for what Adrian wants to do. So, let's start exploring React Native. In this video, you will learn what React Native is and what the motivation is for using it. React Native is an open-source JavaScript library based on React that is used to build cross-platform native mobile apps. React Native was first created by Meta and was used to build part of the Facebook mobile app. Soon it was made open source, meaning that it can be modified by the developer community. React Native is truly a cross-platform mobile library with which you can build native iOS, Android, Windows, and TV apps using JavaScript and React. To add to all these benefits, there's a huge set of components built into React Native. These components include text input, which is used to add a text input box, and style sheet, which serves as a container for styles. This means that you, as a developer, can use these components, which are essentially like building blocks, put them together, and create a mobile app. With React Native, you can create truly native apps using JavaScript and React. But what does that mean? When an application or software is native, it's written for the computer's natural operating system, or OS. For example, a video game can be run natively on a particular game console because it was designed for that specific device and OS. Native-run applications and native code typically perform better and faster because they were created to suit their particular platforms. Normally, you would need to write separate code to make an app fully compatible across different devices. However, React Native has a special trick. It enables you to render applications natively. In other words, your application will use the same programming platform as a native application, despite not being specially created for that device. React Native is written in JavaScript, but renders or generates native code. So, although the code is in JavaScript, it renders to work with the device's processor. Isn't that cool? Traditionally, to build native iOS apps, you need to be proficient in programming languages like Objective-C or Swift. Similarly, to build native Android apps, you need to know Java or Kotlin. These programming languages are used to build the respective native apps on iOS and Android. In this scenario, you have different code bases for Android and iOS apps, and potentially have different teams working on them. But with React Native, you don't need to be proficient with Swift, Objective-C, Java, or Kotlin to develop mobile apps. Instead, you need to know JavaScript, React, and the basics of HTML and CSS to get started. This is because React components wrap the existing native mobile code and interact with native APIs. Recall that an API, or Application Programming Interface, is a means for two programs to interact, and in this case, that happens through JavaScript. All the development is in one code base, but across multiple platforms. So what does that mean? It means seamless cross-platform native apps for both iOS and Android. So, once you learn React Native, you are essentially a cross-platform mobile developer, and you can code both iOS and Android apps with ease. Today, React Native has extended beyond iOS and Android, and can also be used to build Windows apps and TV apps. Okay, so now you know the basics of what React Native is, let's explore some sample code to build a basic cross-platform mobile app that outputs a welcome message. Notice that the code is very similar to React code. However, instead of web components such as the division or paragraph tags used in HTML, React Native uses something called native mobile components such as text and view. Don't worry if you don't know about these components now. You will learn more about them later. The code defines a React component called Welcome App. This component renders a text that says, "Welcome to React Native." The text is rendered using the inbuilt component text, and all of this is wrapped within the view component, which is like a div tag in HTML. Notice before text and view can be utilized, you need to write an import statement to extract each of them from the originating package, which is React Native in this case. Finally, there is some styling for the view component to ensure that the text is centered. When rendered, the code renders the text "Welcome to React Native" on both native Android and native iOS devices. One code base is shared between two platforms. In this video, you learned that React Native is a JavaScript library based on React that can be used to build cross-platform native apps, which include iOS and Android. You also learned about the motivation behind using React Native, as it allows you to build multiple apps using a single code base. Hopefully, this information will help you decide about using React Native to build the Little Lemon app. Mobile apps are everywhere, and many software programs have a mobile version in the App Store. Today, many tasks are done through smartphones, and therefore, becoming a software engineer to do mobile development is a great career choice. In this video, you will explore the different terms that you may come across as a mobile developer. Developers can have different roles in the mobile development space. Native development is the first and the most traditional way of building a mobile app. Native apps are those that are built exclusively for a specific platform. They could be iOS apps, Android apps, or even Windows apps. Mobile developers who work on native app development need to pick and specialize in one of these platforms. You will hardly ever meet a native mobile developer who builds both iOS and Android apps. This is because the skill set to build iOS versus Android native apps is completely different. Let's explore the development requirements for these platforms more closely, starting with iOS. To build a native iOS app, you will be using programming languages such as Swift or Objective-C. These languages are used to build iOS apps exclusively, and you may not find any value in them outside of the Apple ecosystem. You will also need a MacBook to develop native iOS apps. That may be your first purchase as an iOS developer. Now, how does that compare to Android development? Android has the largest number of users today. It is a solid career path to become an Android mobile developer building native Android applications. To develop Android native applications, you would use either Java or Kotlin as the programming language. Kotlin is an open source programming language and is not exclusive to the Android platform. Now that you understand what native development means in the mobile development world, let's address some other terms as well. For instance, what is a cross-platform developer? Although native development is still a good option for a mobile developer, it is not always necessary to build native mobile applications. Cross-platform native apps are becoming increasingly popular. Cross-platform native mobile apps are apps that are built with a single code base for multiple platforms. This means you can maintain one code base and build both native iOS and native Android apps at the same time. You are then called a cross-platform mobile developer instead of an iOS or Android developer. The next term we'll visit is React Native. React Native is one of the most popular cross-platform mobile frameworks that is used to build native mobile apps. It was developed by Meta and made available as open source for anyone to use in 2015. React Native is built using JavaScript and React. What is interesting about React Native is that you code entirely in JavaScript to build native iOS and Android apps. The library that you will use with React Native is, as the name suggests, React. Since JavaScript is also a popular programming language for building web applications, you will find learning JavaScript useful, even outside of building React Native apps. React Native isn't your only choice, as other frameworks can also be used to build cross-platform native apps, such as Flutter and Xamarin. While these frameworks may offer some benefits, such as greater flexibility and more control, React Native has a larger library of components and makes it easier to work with pre-built elements. So far, you've observed what native mobile apps are and what cross-platform native apps are. There is another category of cross-platform apps called hybrid apps, and developers who develop these apps are called hybrid mobile developers. Unlike apps built with React Native or Flutter, hybrid apps do not have access to built-in native features of the mobile device. They use external plugins like Cordova to integrate native features to the app. Hybrid apps render the graphic elements via a browser, which takes several steps to start showing the component on the screen. These are essentially web views. When you are looking for jobs, you will hear these terms frequently, and you will need to be aware of all the different types of developer roles that are available today. In this course, you will be learning React Native, the framework that is used to build cross-platform native apps for both iOS and Android. To be more specific, you'll find out how to use React Native to build an app for the restaurant Little Lemon, which works for both platforms, without the need to write code twice. This means by the end of this course, you'll be a cross-platform mobile developer who can build mobile apps across multiple platforms.
When you learn how to program something, create something using a cross-platform framework, you'll be able to bring that knowledge and create new experiences on new platforms, ones you may not be even thinking of right now. All right. Hi, I'm Eric Hartzog. I'm a software engineer at Meta, and I'm based out of Denver, Colorado. I'm currently focused on using React Native to build applications for the Meta Quest platform. So let's say you have an idea for building an app on iOS, and you build it. You're going to learn all these technologies, all these languages, all these frameworks, and you're going to get it, start it, and create it, and ship it. And that's something that you can do using these technologies these days. And later on, if you want to build something in virtual reality, you'll be able to use those same skills that you learned to bring an experience in virtual reality. And so this is something to be very excited about. Being a developer isn't just about understanding the technology, the framework, the tools, the language. It's also about how you communicate with other developers, with managers, with product managers. It's really a wide field, and it differs a lot depending on what company, what effort you're going into. But pretty much, unless you're completely independently building your own app by yourself, the job is going to require communication. And so it's really good practice to, whether you're in school, to work with teammates and keep that communication, or in a small team, to get that practice communicating technical challenges, realistic timelines, how you're going to approach. And that effort involved at trying to communicate clearly will really pay off, because it's not just a technical thing, it's a long-term skill that will really help out no matter where you're at. My biggest joy in being a cross-platform developer is when we actually ship products to people and make a difference in people's lives. I've been fortunate to have products do this over and over again, and it feels so good when the product is in somebody's hands and they're using it, and you get some feedback such as, hey, this helped me learn some subject material I was struggling with. Hey, this helped me figure out how to do this. And that's something that, as a cross-platform developer, you can identify which device and which app you want to bring, and then help people out. And that feels really good. But by far, the thing I value most is using a cross-platform framework to build an application that is deployed, shipped to somebody, and then makes a difference in their life. And whether it's on iOS or Android, you create an app, you send it out, and it's in the hands of real people using your app to bring some value, some benefit to their life. And that's a great feeling, knowing that something you built is in the hands of people who appreciate it. I hope that you've seen that cross-platform frameworks can do an incredible array of applications, not just building iOS and Android apps, but we can build something in virtual reality, and we can build for future platforms that are not even there yet. So if you're interested in making an impact on people's lives using technology, learning a cross-platform framework and being able to bring apps to production and ship them to people are going to help you make this impact on people's lives. So I wish you luck in learning your cross-platform framework, and I hope you're able to produce fun applications and have a blast doing it.
Before getting started, let me first give you a bit of background about how React Native is used in the real world. There are some eye-opening facts that might surprise you. Did you know that the mobile app industry generates hundreds of billions of US dollars in revenue every year? This goes together with the billions of app downloads that occur each quarter. So, what does that mean to you? This is a great time to be a mobile developer. As a React Native developer, you will be capable of building cross-platform native apps and be a part of this ever-rising industry. Now that you know what React Native is, and you have insight into the different mobile developer roles, let's examine some real-world examples. One popular financial institution achieved greater efficiency when they adopted React Native to build their consumer mobile app for both iOS and Android. Instead of developing a separate iOS version and an Android version in parallel, with no way to share code, they chose React Native instead. This helped them share code and reduced delays and repetition. Another benefit of React Native is that it automatically refreshes code. That accelerated the release of new product features. This resulted in avoiding delays and getting approval from app stores for a new version of the app. Instead, the users open the app and get the latest update automatically. Another success story comes from a multinational e-commerce platform provider. After several years of native mobile development, they decided to switch to React Native. So, what caused them to make this switch? Well, the company already uses React extensively on its web applications. This was a huge motivation to use React Native for their mobile apps, since it uses React as well. This meant that the existing code could have potential reuse, and the learning curve for moving from React to React Native is relatively low. This means web developers who already know React can learn React Native quickly. They also learned, after rewriting some of their popular apps in React Native, that the code between iOS and Android was 95% shared. This was a huge win for their teams. Isn't that impressive? Before moving on, let's talk about one more case study. This time, it's a well-known financial advisor company. Along with the popular e-commerce platform and financial institution, this company also built their mobile app using React Native. Their most desirable outcome with using React Native was reducing the time to market. Their development velocity was very high, and they were able to ship the first version of the app on both iOS and Android within 5 weeks of development. That is really fast. Their observation was the ease with which product engineers can contribute to both React and React Native apps. This led to the collaboration between the web and mobile team, comprising of React and React Native developers, where they can have a shared set of principles, ideologies, and paradigms. Several other popular apps use React Native and have been successful with it. It seems that the biggest benefits for all of them have been the speed of development, sharing of codebase across platforms, sharing of ideas and code between web and mobile or React and React Native, and lastly, the ease of deployment. Are you motivated to learn React Native too? In this video, you have learned some of the real-world use cases of React Native and how they have impacted several companies. Now that you have an overview of the use of React Native in the real world, you may want to know more. You can access further information on this topic in the additional resources in this lesson. In this video, I am going to expose you to an example showcasing React Native code, and this will give you some insight into how React Native code is structured. Let me demonstrate this with some sample React Native code. I open snack.expo.dev. This is a pretty neat tool you can use to write React Native code and also run the code on both iOS as well as Android emulators. You can try doing this without installing React Native locally and just use this as a sandbox. I now have a welcome app component that I've created, and it is currently empty. As you'll note, I am running an iOS emulator. Currently, the screen is blank. Now I am going to display some welcome text within this welcome app component. First things first, I import the view and text components. These components are part of the React Native package. I am using Vue as the parent component, and within Vue, I display some text. Within the text component, I type "Welcome to React Native," and I close the tag. On the mobile screen, the "Welcome to React Native" text is situated at the very top of the screen, but it is barely noticeable. That means that I have to style the layout on the mobile screen to display the text centrally. I am now going to add styling to the view. I give it a Flex1 property and set Justify Content to Center and Align Items to Center. The Welcome to React Native text is now in the center of the mobile screen. So this is an example of a simple React Native component. You have to import the core components from the React Native library and also style your components and display them properly. Click the Android button on the Expo snack. That will launch the Android emulator right away. This is a nice feature since you can write quick React Native code without any setup or emulators, simply on the browser using Expo snack. Wait for the app to launch and the welcome text to display. And there you go. You now have an Android emulator also displaying the welcome app component. If you don't want to install React Native locally while learning React Native, you can always use snack.export.dev, create your own account, and write whatever React Native code you'd like. And you will see them running on both iOS and Android instantaneously. In this video, you observed a basic example of React Native code and took note of the way that the elements are structured. In this video, you will learn about Expo, which helps beginners in mobile development to build native React Native apps with ease. With Expo, you will be able to start right away with minimal setup and build a complete cross-platform app in React Native. Expo is beginner-friendly and is a complete toolbox that you can use to start your React Native journey. So what exactly is Expo? Expo is an open source platform that is used for making cross-platform native apps using React Native. Expo adds a layer of abstraction on top of React Native apps. It provides tools built for React Native, which gets you set up within a few minutes without much hassle. Regardless of whether you use React Native CLI or Expo CLI, you are still writing React Native code to build cross-platform native apps using JavaScript and React. With Expo, however, you will never touch any native iOS or native Android code like Swift, Java, or Kotlin. This is because Expo automatically makes native code compatible with React Native code, and it is not available to the developers who are using it. With Expo, a cool feature that you will enjoy is over-the-air, OTA, updates. Since all of the code will be in JavaScript, you can push updates to your app anytime over the air. You would not need App Store approvals to push updates. This is a big relief to developers, since they usually spend days waiting on approvals from app stores to publish updates to their apps. Anytime you want to deploy an update, you simply click a button to publish, and a new version will be available to your users instantly. Expo also comes with a lot of native APIs built in for both iOS and Android. Native APIs for camera, file systems, location services, push notifications, and so on are already part of the Expo ecosystem. So far, you have heard only good things about Expo. Does it sound too good to be true? Yes, there definitely are a few cautions you must be aware of when using Expo. Let me highlight these cautions. Expo does not have all the iOS and Android APIs. Expo has support for many device APIs, but not all of them. So, you might want to check the documentation of the APIs before you decide to use Expo. If you build your apps using the React Native CLI without Expo, you still have access to the native code. So if you want to write your own custom native component, you could add it to your React Native application if you used the React Native CLI instead of Expo. With Expo, adding customized native modules requires more steps than other options, but it is still possible. If you are looking to keep the size of your app extremely lean, then Expo may not be the best choice, since it comes with several packages and APIs that you may not use. At the end of the day, you can always eject from an Expo app. That said, if you decide to build your mobile app using Expo, and 6 months down the line you have additional requirements that may be better off without Expo, you can eject your app from the Expo ecosystem. This does come with a cost though. You may have to refactor some code to use other libraries that are not part of the Expo ecosystem. Although there are some warnings about using Expo, it is still highly recommended for novices who are just venturing into mobile development. Expo shields you from some of the pain points with mobile development. This will help keep your learning journey less stressful. Expo is still the fastest way to build a React Native app. Let me just summarize the pros and cons of using Expo for you. The benefits of using Expo are that the setup is easy, you don't have to have any prior knowledge of iOS or Android code, and Expo comes with a lot of built-in APIs. The caveats or cautions are that not all iOS and Android APIs are included. There are sometimes poor integration of custom modules, and app sizes can be large and not lean. In this video, you learned about Expo CLI, its benefits for beginner mobile developers, and what you need to be aware of when using Expo CLI. You now understand that Expo CLI is an added layer of abstraction on top of React Native and can be potentially used to set up React Native apps with ease. In this video, you will learn how React Native components are categorized and how different sets of components are used to build apps. To explain all of this, I am going to focus on what you need to understand to build the mobile app for the Little Lemon restaurant. So far, you've learned a great deal about React Native, and you're ready to start building the Little Lemon mobile app for Adrian. As you can imagine, the mobile app will have several components. So, you first need to understand React Native's components and their structures, as they are needed to build the mobile app. In React, you use a basic building block to build the UI, namely a component. Components let you split the UI into independent, reusable pieces. When you put all of these independent pieces of components together, you build a complete app. The same concept is true for React Native as well, since it is built using React. Let me refresh your memory with the code I added to display a Welcome to React Native message on the mobile application. It is a custom component called Welcome App, which renders a welcome text in the center of the mobile screen. This is one reusable, independent piece of UI. These types of components are called React components. You will develop several React components while building your React Native applications. Several of these components will be reusable, such as headers, footers, menu bars, images, and so on. They all come together to make one complete mobile app. As you build mobile apps, you will work with several other components while using React Native. Now let me tell you more about the different types of components. They are broadly called the React Native components and are classified as core components, community components, and your native components. You might be wondering what these categories mean. Let me tell you more. React Native comes with several core components that do not require any additional packages and comes with the React Native package. These core components include view, text, image, text input, scroll view, and many more. They are ready-to-use native components that you can use to start building your app right away. A great feature of core components is that they translate into native iOS and native Android components. This means they can adapt to work with your device's native functionality without the need for specialized code. You do not need to concern yourself about how that happens. React Native takes care of the translation from JavaScript to native mobile code. You can start using them right away to build your apps. This is the whole purpose of using React Native. Ever since React Native was open sourced, it has attracted plenty of developers. The community around React Native is growing strong, and many components are created by the community for the community. These are in addition to what you get from the core components, which we call community components. The popular community components include React Navigation, React Native Screens, React Native Maps, React Native Video, and many more. Since React Native relies heavily on the use of community components, the original package by itself is quite lean. You can choose the community components based on the needs of your app. For example, navigation between screens is not a core component. However, React Native offers you the flexibility to choose a navigation library of your choice to add to your application. This means you can modify existing components or create your own and make them available as open source for the community. Pretty cool, isn't it? Now, let me help you to explore the last type of component. In addition to the core components and the community components, you can also create your own custom native components. React Native lets you build custom iOS or Android components based on your application's unique needs. These are your native components, and you own them. These are written in native code, which means working with native iOS code in Swift and Objective-C, or native Android code in Java or Kotlin. They are usually built by developers who are experienced in native mobile development. But you shouldn't be intimidated about being an experienced developer. In most cases, you will not need to build native custom components, since there are plenty of core components and community components available that cater to most use cases. And if you want, you can make them available as open source for the community. In such a way, you can in return contribute to the community, where they will be available as community components. In this video, you learned that there are core components that are built into React Native, community components that you can install and use in your React Native app, and custom native components that you can create for unique use cases. Along with these, you can create your own React components to build the complete mobile application. All of these put together make the React Native components. With all these different types of components that can be put together to build mobile apps, you certainly have a lot of possibilities to build the functionalities Adrian needs for the Little Lemon app. In this video, I am going to demonstrate how you can build your very first component using React Native. Recall that React Native is a collection of components. You get your core components, like the View component, from the React Native application. Then you get community components, which are components that you get from the community packages that you must install. Lastly, you get native components that you create yourself. Keep in mind that all of these belong within the umbrella of React components. React Native is essentially written in React, which means you can create as many custom React components as you'd like. You can, for instance, create a component for the header, a component for the footer, one for the menu bar, and so on. Components are essentially reusable pieces of code, and you can create as many React components as you'd like. In my example, where I am building a Little Lemon restaurant app, I need to display a header that says Little Lemon Restaurant. Let me demonstrate how this is done. To create a reusable header, I need to have a components folder in React Native. If you don't have one, create a components folder, and within the folder, create a new file. I call the file littlelemonheader.js. This is where I'm going to add the code for the header. Now, within the littlelemonheader.js file, I'm going to copy and paste the component that I have in app.js. I'm calling it Little Lemon Header. Notice that all React components have to be capitalized and need to begin with a capital letter. Within the Little Lemon Header component, I am going to add text for our header, namely Little Lemon Restaurant. The text component will be rendered within the parent view component. That will be the header text that is displayed on the mobile screen. My header component is now ready. It's a reusable piece of code, and all it does is display the header text, which in this case is Little Lemon Restaurant. Now, anytime I need this header within this application, regardless of whichever screen it's on, I simply use the same header component. Isn't that neat? Now, let me go back to my app.js file and utilize this component. Firstly, I need to import the component that I just created. I am going to use the import keyword to import our Little Lemon Header component from the components folder. Your IDE, like VS Code, should be smart enough to find the component. So, it found it in component/Little Lemon Header. Now, within the app component, which is basically the root of my application, I'm going to render the Little Lemon Header component. So, within the view component, I can call the Little Lemon Header component, and that's it. My app is now ready. It is basically utilizing the Little Lemon Header, which is the reusable header component. How does this header now display on the emulator? Notice that the text is on the very top, because I haven't styled it. To display this better, I am adding a style property to the view component, as well as the flex1 property. I am then adding a justified content of flex start, and I am also including a padding of 45 pixels. When you now go back to the emulator, the header is visible. There you go. You see the Little Lemon Restaurant header being displayed on your emulator. On your IDE, what's cool is if you have components that you've created, you can always right-click on your new component and then click on Go to Definition, and that will take you to your newly created components. And this is neat because you have the app component calling this custom header component that you just built. You have now learned how to build your first component using React Native. Go ahead and practice this new skill. That is the best way to learn. You're probably ready to start working on the Little Lemon app, but before you begin, let's explore some important React Native components that you can use. In this video, you will learn to use two core components in React Native, namely view and text. You will also apply properties to fulfill the needs of your use case. The very first thing you want displayed in the Little Lemon app is a welcome text. In mobile development, a view is the basic building block of the user interface. It is a small rectangular element on the screen. The view houses all elements within it. It is the very first component you will need in your app. View is also the most fundamental component for building your mobile UI using React Native. The view component is like a non-scrolling div tag in the web world. View is a container that supports the layout of your mobile screen. You can use styling, flexbox, touch handling, and provide accessibility controls within the view. Don't worry if you're not familiar with these terms now. You will cover them later. The view component can also be nested inside other views and can have 0 or many children within it. Now, what is the text component? Let me tell you more. Text is a basic core component from React Native that is used for displaying text. The text component supports styling, nesting, and touch handling. Again, you will cover these terms later. Just keep in mind that text is a commonly used component, and you will use it any time you want to display text on your mobile screen. Let's explore a code example with a view component, which also houses a text component. You can start by defining a React component called Little Lemon Welcome. Then, you can use both core components view and text. The view is the parent element within which the text component is rendered. The view component takes in a prop called style. The style prop, as the name suggests, can contain the styling information for the view component. For the styling, I have added 2 margin parameters, a 40 pixel margin on the top and a 40 pixel margin on the left. The outcome of these 2 parameters is that the text component displays the text on the screen within the view element and contains the margin on the top and on the left. Let me demonstrate the impact of styling on what is displayed on the screen by changing the font size, the font color, and the background color. The font size is increased to 30, and I have also given color to the text. In addition, a background color has been added to the view component as well. When I check the app in the emulator, the code now renders a much larger text that is displayed with the background color of the view and the welcome text color. In this video, you learned how to use the 2 basic core components of React Native, view and text. You also learned some of the basic features of these components and their usage. Now you can work on designing basic screens in React Native for the Little Lemon mobile app. In this video, I will demonstrate how to use the view and text components using the Little Lemon restaurant app. The core components of React Native are view and text. In the root level component, you have view as the parent component, and within this view, you can have 1 or many children. The Little Lemon header component is a child of this view component, and I've passed some styling properties to the view. I've given it a flex property of 1 and a green background color as displayed on the emulator. Flex 1 means that the entire mobile screen is taken up by this view. This is because it's the parent view of the root component. When I change the background color to pink, you'll note that the background of the entire screen changes to pink. But let's change it back to green. Now, within the view is the Little Lemon header component I created in another video. This is the header component, and if I go into that, you'll note that it's also wrapped within a view. If I display some text, it has its own view as well. Let's try styling this view to highlight the different aspects of view styling. I'm going to give it a flex parameter of 0.5. What this means is that the view will take up 50% of the parent view's space. It's not really visible on the emulator, so let's change the background color of this component. You'll notice that the pink color of the Little Lemon header component takes up 50% of the parent view's space, which is half the screen. If I change it to 0.3, then it'll take up to about 30% of the screen. And if I change it to 0.2, then the view of the header takes up 20% of the space on the screen. Now let's change this back to 1. You'll notice how it overrides and takes up all the space on the screen. In other words, it takes up the same amount of space as the previous view, which is the parent. And the pink color overrides the green color. Let's go back to 0.2. That seems like a reasonable amount of space for the header component. Now, let's change the color from pink to something that's more apt for the Little Lemon restaurant. I'm going to give it a hex code value for this yellow color that kind of looks like a lemon. All right, now you understand that views can be nested. In other words, you can have child views, and you can use the flex property to determine what percentage of the view the child view will take up compared to the parent view. Let's examine the text component next. Text is also a core component of React Native, and all text strings must be wrapped within the text component. Note the red warning screen that comes up when I remove the text component and add a text string within the view component. The warning specifies that text strings must be rendered within a text component. In other words, it's a requirement in React Native. Any text that you see on screen must be wrapped within the text component. So let's add that back. Now, there's a padding of 40 pixels, and I can add several styles to the text component. I'm going to make the font size larger and set the color to black. The text is now much bigger because I increased the font size. An interesting thing about the text component is that it accepts nesting. This means that you can have a text component within another text component, and you can nest the styles. In other words, if you nest text components, then the child text component can inherit the properties of the parent text component, and you can override some styles. Let's do that now. I close the parent text component tag because I'm going to create another text tag. In here, I'm going to add some more text. Since the text in the parent text component reads "Welcome to," for the child text component, I type "Little Lemon." When viewed in an emulator, notice that it appears like all the words are part of one text component. This is because the text component with "Little Lemon" inherits all the properties from the parent text component. However, I can override specific styles. For example, I can apply bold font to the child text component. Then, when I return to the emulator, notice that the words "Little Lemon" are now in bold, while the rest of the words are in normal font. You can override style properties like font weight, color, padding, and so on, but still inherit the parent text component styles. Another useful property is the number of lines property. It tells React Native how many lines are allowed within a text component. Let's say I specify that the number of lines allowed is 1. This means that anything that doesn't fit in one line will get cut off. So on the emulator, the text is cut off in the middle of the word lemon, because that's how many letters can fit on one line. This property is useful when you have a large amount of text and forms, especially because you can use this feature automatically. Now, when I change the number of lines to 3, you'll note that all the text is displayed because it's less than 3 lines long. In this video, you learned how to use the View component to set up the basic visual layout of your mobile app, and how to use the text component to add and style the text to be displayed on screen. In this video, I'll refine the Little Lemon app by using the Scroll View component to create a scrollable list. I'll also demonstrate how to apply styling separately to the Scroll View component and the child components that it contains. Finally, I'll apply a few common props of Scroll View to customize its functionality. Let's review what's there so far in the app. There is a Little Lemon header component that is a custom component, and the root app calls the header. But what if I want to display the menu on screen? To do that, I create another component within the Components folder called the Menu Items component. At the moment, it's empty. Note that I already have the names of the menu items filled out. Now I'm going to build out the Menu Items component. It will display the menu items in a large font so that you have a scrollable list for a mobile screen. First, I have a parent view, and within it, I call the Scroll View component because I want to display some text in the Scroll View component. So users will know that a list of menu items will follow. Then I have another text component, and that's where I'm going to display the menu items. How do I do that? I use the Menu Items component and the ToDisplay array. Keep in mind this is going to be in a scrollable list. I also have to decide how much flex I'm going to give this view. The header takes up about 10% of the screen, so I specify flex 0.75, which means 75% of the rest of the screen will be taken up by menu items. I'm also going to add some styling to the Scroll View component. I add horizontal and vertical padding of 40 pixels. And for the background color, I use the hex code for the green I've been using so far. Let's add some basic styling to the view menu text as well. I add font size, flex wrap, and a color. Here is where I'm going to display each menu item, and for that area of the screen, I select the lemon yellow color, and I use a large font size. So, let's recap. I've added a view with 75% of the remaining part of the screen. I added the scroll view with some styling and a background color. And then I have the text here, which is going to display each item in this array. The next thing I need to do is call this component from the app. I go into the app.js file. Just like I imported the header in a previous video, I'm now going to import the menu items component. And the IDE already knows where it's located, so it auto-suggests its location and I can just select it. I place the menu items component under the header and I ask for it to be rendered. What you'll note in the emulator is the little lemon header component, and right below it you see the menu items component. Every item on this list is displayed, and it's done within the scroll view component. The next test is it scrollable? And yes, there you go, it is. It's a scrollable list that I built using just the React Native scroll view component. The view menu text is part of the scroll view as well, and each item on the menu is there too. And that's how you build a scrollable list in React Native. The scroll view component also has several features and props it can accept, so let's examine a couple of those. I pass the horizontal prop through to the scrollable list. And what happens is that the list isn't a vertical scroll bar anymore. It now scrolls horizontally. Because I want to have a vertical list of items, I change this to false. But now you know that this option is available to you in case you are building a horizontal list of items using the scroll view component. Let's change the background color of the menu items component so I can demonstrate something. So, within the scroll view, I'm going to change the background color to black. Note how 75% of the screen below the header component is black. The rest is still the old green color, which is part of a different view, and which I can use as a footer. But I don't really see a scroll indicator. This is where the prop indicator style comes in. I can choose black, white, or default, which is also black, for the indicator. Since the background color is black, I choose a white indicator. And there you go. There's a white indicator on the right side now, and it disappears automatically when I stop scrolling and reappears when I'm scrolling again. You should choose the color of your indicator based on what your background color is, so that it's visible against it. There are plenty of other properties that come with scroll view. If you press Control Space within here, you'll notice a lot of other properties and functions. So make sure to read the React Native documentation to explore some of these other properties too. In this video, you learned how to use the scroll view component to build a scrollable list of menu items. You also styled the component and its children, and you became familiar with useful scroll view props such as horizontal and style indicator. So far, you have encountered some basic core components of React Native, such as view, text, and scroll view. You explored examples of styling each of these components, but all the styling was done within rendering of the component. This can make the code harder to read because all the styling is lumped together with the rest of the code. Fortunately, React Native provides a solution to this. In this video, you will learn about the Style Sheet API, which you can use to extract styles from the component's render, keeping all the styles together. Inline styling is when you keep all the styles within the component's render. As your application grows, this method of inline styling can get unmanageable very quickly, and the code is harder to read. Let's examine an example in which a text component is inside of a view and different styling is applied to both. The code is intertwined with the styling to the point that it is hard to make sense of what is going on. It seems almost like a cobweb of styles mixed with code. However, if you keep the component code and the styling for the components separate, you will have a cleaner code that is easier to read and understand. And you can do that using the Style Sheet API. React Native provides Style Sheet, which is an API that is very similar to CSS style sheets. The Style Sheet API allows you to move styles away from the component's render. Creating styles using the Style Sheet keeps all the styles together, making it easier to understand. Let's explore an example style sheet that contains two styles. The first style defined in the code is named container, which will be used for the parent-level view within the component. Flex 1 has been added, which means the view is going to occupy all the available space on the screen. There is also some padding, a margin at the top, and a background color of white. The next style that is defined is called the title. As the name suggests, this is the style that corresponds to the title, which is displayed using the text component. Now let's find out how this style is referenced within the component. Wow, the component is now much smaller, cleaner, and more readable. It is also easier to understand. There is a parent view, which wraps some text, and all the styles come from the style sheet which was defined earlier. And that is it. When the code is compiled on a mobile screen, it displays the text Little Lemon Restaurant and takes the styles that were defined in the style sheet. By using style sheets, you have moved the styles out of the component rendering section, cleaned it up, and given each style a meaningful name. Once these styles are defined, you can reuse them if needed, instead of redefining them. Always keep the styles close to the component within the same file. That way you can quickly reference the style for that component. If you were to define global styles for your app that will be used across several components, then you can move the global styles to a separate file which will be referenced by many components. It's a much cleaner and easier way of doing things. In this video, you have learned how to extract styles using the style sheet. You are now aware of the benefits of using style sheets, such as improved code readability, separation of concerns, and meaningful naming of styles. So far, you have learned how to use some of the core components in React Native, such as view, text, and scroll view. And now you're ready to learn a little more about writing cleaner code in React Native. Some of the component code I've written for the Little Lemon app is actually quite hard to read. I can note the component it's rendering, but it's cluttered by all these styles. It's quite hard to understand what's really going on. And here's where the Style Sheet API is very useful. The React Native Style Sheet API is quite similar to CSS style sheets. It helps you move all the styling outside and add it to the style sheet instead of using it within the render method of a component. But how does that help? By moving the styles away from the render method, I'm making the code easier to understand. Another benefit is that I can use descriptive names for each of the styles, which makes it easier to add meaning to these low-level components. So, let's go ahead and explore how to use the Style Sheet API to make code cleaner and more readable. First, I have to import the style sheet from React Native. Within the same file, I'm going to create a constant that I'll call menu styles, since I'm writing styles for the menu. It's easiest to use a descriptive name. Using the Style Sheet API, I'm going to call .create, because this is where the styles sheet will be created, and it will store all the styles I add into it within the menu styles object. The first thing I'll address is the style that I've used for the view here. So I take the flex.075 out and I create a new style name that I name container, because this is going to be the view container for the entire scroll view menu. And I'm going to add the view style here while I remove it where it was, along with the extra curly braces. In place of it now is the menu styles object I just created. And the container property is auto-suggested because the IDE is smart enough to recognize it. And that's it. I basically took away a bunch of style and added it to the style sheet object that I've plugged in here. Let's do the same with the next style. I'm going to call the scroll view style the inner container. I paste all the scroll view styles right here in the inner container. And I'm going to do the same again. I get rid of all the styles from here where the component is rendered. I use the menu styles object again, and this time I look for the inner container property. Can you see how this code is cleaner already? Let's go ahead and do the same with some of the other styles for the text component. I take all this styling out, the color, font size, and flex wrap. I paste it into a property I name header text, because that's what's going to display the view menu. And now I repeat the same steps. I look for the menu styles object and for the header text property. And there you go. Just one last item to extract the style from, and the component will be complete. I'm going to name this one item text because it's going to display the text for each item. I get rid of the extra curly braces and all the styles. And then I use menustyles.itemText, and that's it. Now the component is all cleaned up. It's now much shorter and easier to read because it doesn't have any styles in it. And I've used descriptive and easy to understand names for each of the styles. Now, I know there's a view, and within the view there is a scroll view with some properties. And I have two text components. One which displays the header text called View Menu, and another that will display the item text for each menu item. Just by reading this code, I understand what the component is really doing, and I can always scroll down to look at the styles, and they're all together. If I have to make changes to the styles, I'll come here to make the changes which will reflect within the component. Using the Style Sheet API just makes the code easier to read, doesn't it? Now, let's go ahead and clean up all the other components like the little lemon header and the app. It's much cleaner when you put all of your styles together in a style sheet. Here is the little lemon header component all cleaned up. I have a container style, a header text style, and an inner text style. The component looks much cleaner. And here you can see all of the styles collected in the Style Sheet API. I used the same approach with the app component, which looks a lot shorter and cleaner now. It just has a view, and it calls the little lemon header and the menu items component, while the style is right here. Make sure to use the same approach with Style Sheet API anytime you write React Native components. Not only does it keep your code cleaner, it also keeps the styles closer to the component. In this video, you learned how to use the Style Sheet API to store styles so that your code is cleaner and more readable. Well done! You've reached the end of the Introduction to React Native module. Let's take a few moments to review what you learned during this module. You began the module with a course introduction in which you were exposed to the basic concepts of React Native. Now that you've completed this lesson, you can describe what React Native is, explain the motivation behind using React Native, and describe terms related to native, cross-platform, and hybrid developer roles. You should also know how to apply steps that will help you to be successful in this course and set up a React Native project in VS Code using React Native CLI. You then moved on to the next lesson, in which you had a proper introduction to React Native. Having completed this lesson, you can now describe the basics of React Native, explain the benefits of using React Native over other languages for mobile development, and describe how React Basics is used in the real world. You also learned what the Expo platform is and how it can be used to build cross-platform mobile apps, and how to build a simple React Native app with Expo code. You then undertook the third lesson in this module, in which you learned about React Native components. Following this lesson, you should now be able to describe how React Native components are categorized, explain how different sets of components are used to build apps, and describe a basic overview of React Native components. You should also be able to build your very first component using React Native. In Lesson 4, you learned everything about views, text, and scroll views. You should now be able to demonstrate how to use the two basic core components of React Native, view and text, describe the basic features of these components and their usage. You should also be able to demonstrate how to build a scrollable view by using the scroll view component and describe its basic usage in React Native. In the last lesson of the module, you learned about styling components. On completion of this lesson, you should be able to explain what inline styling means, describe the benefits of using style sheets. You would have experienced some practical styling examples to assist you in the future. You have worked through some coding exercises and have become familiar with the basics of React Native. That's a great start to your learning journey. Previously, you learned how to use the scroll view component to create a scrollable list of items in your React Native app. Recall that the scroll view component does this by rendering all child components at the same time. While this provides a very useful functionality, it does also introduce the issue of slow rendering times for large lists. Fortunately, there is another approach that can enable faster performance. In this video, you will learn about the flat list component, which can also be used to display scrollable lists in a React Native app. You'll come to know that in contrast to the scroll view component, rendering time with flat list is not affected by large lists, thanks to an approach called lazy rendering. You'll soon find out how it does that, but first, let's return to the Little Lemon app to demonstrate how flat list can be useful. In addition to the text list of menu items, Adrian wants you to add an image of each item. This should be incorporated into the same list so that the user will see the image beside the item as they scroll through. In other words, the list will be much larger than before. Let's say you need to display 100 images in total. With a scroll view component, the user would have to wait for all these images to load before they can experience the app as intended, and this could take quite a long time. So, what is the solution to this problem? React Native has another built-in component that can render large lists efficiently, the flat list component. This component renders the items lazily. What does lazy rendering mean? Well, instead of rendering the entire list at once, it only renders the items of the list as soon as they need to appear on screen. In addition to lazy rendering, the flat list component can take on the features of the scroll view component. To better understand the benefit of lazy rendering, let's first revisit the scroll view component. An app using this component would render all items in the list at once, regardless of whether or not they are on the screen at that moment. In contrast, with lazy rendering, items are only rendered when they are about to appear on the screen, and are removed when the user scrolls away from them. This results in faster rendering and superior performance. So, to render hundreds of images in the Little Lemon app, it will be much faster to use the flat list component, as it will only render the images that are on the screen and are about to appear on the screen. The moment you scroll away from the images, the next set of images are rendered, and the previous set is removed. Isn't that neat? Now, let's examine the syntax for the flat list component to find out how it can use scroll view features in addition to its own. The flat list component inherits all the scroll view component's props. Notice that the example code has two props, data and render item. Both of them are required props of the flat list component. The syntax for render item contains three elements. The item is an object that represents a single item from the data array that is passed to the flat list. The index represents the unique index corresponding to the specific item. Finally, you can also pass the optional separators, which can be used to highlight or unhighlight items. In addition to data and render item, there are several other optional props that can be passed to the flat list component to define the header, footer, separator, and many more. You will learn how to use flat list with commonly used props by exploring an example of each. In this video, you learned about the flat list component and why it is used. You also discovered that it is built into React Native and improves performance when rendering large lists. Finally, you've become familiar with what lazy rendering is and how this approach is used by the flat list component to render large lists efficiently. In this video, you'll explore how the flat list component can be used to render a large, scrollable list of items in a React app. During this process, you'll learn how to use the data and render item properties to pass props to the flat list component. Imagine you have a very long list of menu items that you want to display in the app for the Little Lemon restaurant, which spans several screens. Let's find out how to do this while maintaining a fast, smooth app experience for the user. I've opened the file for the menu items component. In here, I have an array called menu items to display. When I expand this array, you'll find that it contains all the items that are in the menu of the Little Lemon restaurant. Notice that each item has a name and a unique ID associated with it. Now let's find out how you can utilize the flat list component to display this item on a mobile screen in a performant manner. First, I need to import the flat list component from React Native. In the return statement of the menu items component, I'll then render the flat list component. Note that there are two properties that are required when you're using the flatlist component, the first being data. Data represents the array that is going to contain the list of items. So in this case, it's menu items to display. So I'm going to pass this entire array to our flatlist component by typing data equals, followed by the item name in curly braces. The next required property is render item. Render item is essentially a function that the flatlist will use to go over each item in the array. So I've passed in the array and set up a function to go over each item inside of it. But I still need to tell the app how to render the items individually. To do this, let's create a function that will be called once the render item is invoked. Prior to the return statement in the menu items component, I'll create a render item callback function. It will have each menu item from the array and will render a component called item. To this component, I'll pass the name of the item as the prop. The reason why I am passing the name is that each menu item has a name property assigned to it, as you might recall from the array. All right. Now the next step is to create this item component. So the render item is going to render each item and it's going to pass in the name attribute. But where is the item component? I haven't created that yet, so let's take care of that now. So outside our menu items component, I'll create the item component and give it the prop name so that it gets that data from the parent component. I'll also give it a style of the inner container, which I've already assigned. Inside of the view tags, I'll add an HTML text element to show each item name when the component is rendered. Notice that the item component gets the name as a property and I can simply display it. But how does that get the property? Again, that is achieved with the render item method. The flatlist component is now complete. The required props have been passed, the data is retrieved from the array in the menu items to display component, and the render item method can automatically parse through each item in the menu array. I also created a smaller component called the item component, which makes the code more readable and displays the menu item name. To wrap up, let's examine how the app appears in an iOS emulator. You have a View Menu text header and a list of items on the menu. If you scroll down, more items will appear. Remember, this is not built by the scroll view, which means that items are only rendered as you encounter them and are removed when you scroll away. This makes for a much more performant component for handling such a large list. In this video, you learned how to use the flatlist component to efficiently render a long list of menu items, such as the one that needs to be displayed in the Little Lemon app. This includes using the component's data and render item properties to pass props to it. In this video, you'll learn how to use a few of the more useful methods that are found in the flatlist component. Specifically, you'll extract the unique IDs of your items for easier tracking, and you'll render separator lines, a header, and a footer for your app. I've opened the file for the Little Lemon mobile app, in which I previously used flatlist to display a scrollable and lazily rendered list of the restaurant's menu items. When I expand the array that is stored in the menu items to display component, notice that it is essentially an array of objects. Each item has a name as well as a unique ID. For example, there is 1A, 2B, 3C, and so on, without any repetition. The reason for each ID is that they will be used in the flatlist component. Specifically, I'll pass a prop to the flatlist component known as the key extractor. I'll begin that by typing key extractor between the flatlist tags inside of the return statement for the menu items component. What this does is extract a unique key for a given item at the specified index. Why would you need this? Well, a key is used for caching and as the React key to track item recording. Remember that if you are using flatlist to render a large list of items, each item is given a key. Just like you would use a key for lists in React, you would also use a key for lists in React Native. So, for key extractor, I'll pass our item and let it extract the item ID. I can type this as item in parentheses, followed by an arrow function operator, and then item.id. So when I run the code, key extractor will look for a key for each item in the list, but it does not change anything in the UI. The next thing I want to demonstrate is how to use the flatlist component to generate headers, footers, and separators. Let's start with a separator component that will render a separation line. I'll create a new component and name it Separator. In here, I'll render a view and then pass in an existing style for it, which will show a separator line with a bottom border width of 1 and also applies a border color. To do this, I'll open a view tag and type style equals, followed by menu styles.separator in curly braces. This will extract the separator style from the menu styles component where it is stored. Now the separator component has been created, but how can I use it within the flatlist? Well, flatlist has a prop which it can take called item separator component. In the flatlist component, I type item separator component and then pass in the separator component that I just created. Now the flatlist knows how to render the separator, so let's check it out in the emulator. You'll find that there is now a separator line between each menu item, and this comes from the separator that was just created using the item separator component prop, which was a part of the flatlist component. Note that you're not limited to using lines as separators. If your use case calls for it, you could also use images. Just like I created the separator component, I could also create other components within the flatlist that will automatically be detected and rendered. One such component is the header component. Currently, I have the header written as part of the render method in the menu items component. However, I can move it to its own component instead, so I'll create a new component called header, and this time it will render the text view menu. So instead of making the header a part of the render, I'll pass it as a header component to the flatlist itself. The prop you'll need to pass is called list header component, and to that you'll pass the header prop. Let's check the app in the emulator again. Initially, the header appears the same as before, but recall that it is now part of the flatlist. This means that when you scroll down the list, the view menu header moves off screen. In contrast, the page header stays in place because it is a separate header that is not part of the flatlist. Now that we have a header, let's finish off by creating a footer for the flatlist component. This will be a similar procedure as I did with the header. I'll create a new component called footer and apply a style which is stored in the menu styles component. In the footer, I'll render the text all rights reserved by Little Lemon 2022. In the flatlist component, I'll add the list foot component prop, and to that I'll pass the footer component that I just created. And now, checking the app in the emulator once more, you can scroll to the very bottom and find the footer rendered as part of the flatlist. In this video, you became familiar with how to use the key extractor prop to extract unique item IDs. You also learned how to render separator lines with the item separator component prop, render a header with the list header component prop, and render a footer with the list foot component prop. This was all done inside of the flatlist component using built-in methods. Well done. Previously, you learned about the flatlist component, which can be used to render large lists without sacrificing app performance. In this video, you'll become familiar with another performant component called section list that's used for rendering large lists by section. You'll also learn how section list and flatlist differ and why section list might just be what Little Lemon needs to organize their menu effectively and efficiently. Adrian had you use flatlist to render a large list of menu items in the Little Lemon app. As a result, it loads very quickly. That's great. However, there is room for improvement from a practical perspective. Currently, the entire menu is presented as one long uninterrupted list. This can make it difficult for users to locate specific items. To make things tidy, one thing you could do is divide the list into sections. Each section would have its own unique header that describes the contents. So, how can you accomplish this? This is where section list comes into play. Section list is another built-in React Native component that has the same features found in the flatlist component, but it also supports the separation of items in a list. So let's start by comparing the flatlist and section list components. Much like flatlist, The section list component uses lazy rendering to achieve faster rendering. Recall that this is done by rendering items only as they need to appear on screen and removing items that are no longer in use. Also, like FlatList, section list inherits the props of the scroll view component. This means that the features of scroll view can be used in addition to those of section list. Now you're probably wondering why you would choose section list over FlatList. Where section list differs is that it provides support for section headers and section separators. For the Little Lemon app, this means that instead of presenting a solid, uninterrupted list, you can break it up into smaller chunks and add appropriate headers, such as appetizers and salads. So in the end, using section list to render your menu not only achieves better performance, but it also enables you to present your menu items in a more pleasant and easy-to-read format. Now, let's examine the syntax for the section list component that you'll use in your app. Notice that the two required props this time are sections and render item. Sections refer to the array of available sections and contains the actual data to render. It is comparable to the data prop in the FlatList component. Render item is a method which acts as the default renderer for every item in each section. To break it down further, render item contains 4 elements: item, which is an object as specified in the section's data key; index, which represents an item's position within the section; section, which represents the section object as specified in the section's prop; and separators, which is an object that can be used for highlighting, unhighlighting, and updating props. So that's one way you could make use of the section list component, and the general syntax used to write it. But there's more. Once again, just like FlatList, there are several optional props that can be passed to the section list component. These allow you to perform such tasks as defining the header, footer, separator, section header, section separators, and many other elements. You'll observe some examples a bit later that demonstrate how to use section list with some of the most common props. In this video, you learned about the section list component and how it can be used to apply separation to the list in your mobile app. Much like the FlatList component, it also renders items lazily, which is exactly why Little Lemon will benefit from its use by using it to separate its menu into specific categories. But it goes further and allows you to break up lists with headers and separators. What a versatile tool! In this video, you'll learn how to use the section list component to render large lists by section and to create separate headers for each section. By this point, you should know that section list is similar to the FlatList component, with the exception that section list also has support for rendering section headers. Let's explore the array stored in the menu items to display component, which I've tweaked slightly from the previous examples. The array items are the same, but this time they've been grouped into categories. The categories are appetizers, main dishes, sides, and desserts. When I render this list, I want to display section headers for each of these categories. This is a perfect opportunity to use the section list component. The first thing I'll do is import the section list component from React Native. I have some components here from the previous examples that haven't been used yet. Specifically, I have the separator component, the footer component, the item component, and a menu items component. I'll place the section list component within the menu items component. The section list component, as I mentioned, is very similar to the FlatList component. It requires 2 properties. The first property which is required is the sections property. Now to the sections property, I'll pass the name of the array that contains all of the data. In this case, it's menu items to display. This is similar to the data property that you encountered in the FlatList component. Another required property is render item. This calls the render function that will render the entire item. I'll pass to this the render item function, which hasn't been created yet. So let's take care of that now. To do so, I'll create a component within menu items called render item that will contain item as the property, which is the array that contains all of the data. It will render the item component that I've previously created, and the name property for the item component will be that specific item itself. So to summarize what this code does, I'm passing the function renderItem to the renderItem component. This function will then parse through each item and call the item component. And within the item component, there is a view which displays the name of each item. In this case, the items are from the array within the menu items to display component. In addition to the render item, there are also section headers that I need to render. To do this, I'll add another prop in the section list called render section header. And to this, I'll pass a function that is also called render section header. I then need to create this function and have it take in the section. The section will be extracted as the titles in the array, such as the appetizers, main dishes, and so on. Next, I'll add a return method to render this information as the text that displays the titles. I also want to add some styling to this text, so I'll call in the existing section header style that is stored in my menu styles component. This style will set parameters such as background color, font size, and text alignment. All right, so now I have the basic section header component written. To summarize, what it does is take in the sections from the array, render each item from the menu using the renderItem method, and render each title object in the array as a section header. Let's check out how this appears on the emulator. You'll find that there is a header for Little Lemon, as well as section headers for appetizers and main dishes. The items are also listed under each header correctly. For example, the items under appetizer include hummus, falafel, and eggplant salad. The other sections appear as I scroll down the page. This is iOS emulator, and an interesting detail here is that when I scroll, each section header sticks to the top until I scroll to the next section. The app behaves slightly differently in Android, so let's jump over to an Android emulator to find out what changes. In Android, you'll notice that the header sizing is different. As I scroll, you'll also find that the section headers disappear as I move past and do not have the sticking action that is present in the iOS version. What this means is that the section list component renders natively for iOS and natively for Android to produce the native experience for each platform. You'll probably notice more subtle differences like this as you continue to develop in React Native and test your apps on different platforms. Let's finish up by adding a few more details to the section list, just like I did previously with FlatList. I'll create a separator component by adding an item separator component prop to section list. And to that, I'll add the separator line that I already created. I also want to add a footer, so to do that, I'll add the list footer component prop and pass it to the footer. Let's check these updates in the emulator once more. And there you go. The finished section list has separator lines between items and a footer at the bottom that displays copyright information. In this video, you learned how to use the section list component to render large lists by section. As part of this, you used the render section header function to extract section header data from an array and render it as text. Additionally, you came to understand that section list is rendered natively across mobile platforms, leading to slightly different experiences depending on the device being used. Up to this point, you've learned about several components available to you in React Native for the purpose of displaying app content in a performant way. But what if you want to advance beyond consumable content and bring more interactivity into your app? That is the topic of this video. In this video, you'll learn about text input, a foundational component in React Native for inputting text into the app via a keyboard. You'll also examine a few different use cases to help you understand where and how it can be applied. The team at the Little Lemon restaurant loves to hear from customers, whether it's sharing great experiences or offering ideas for improvement. To make this an easier task, Adrian wants to incorporate a feedback form into their mobile app that allows users to type in their name, contact details, and a custom message. To make this happen, you can use the text input component. Text input is a built-in core component of React Native that allows text to be input into the app through a keyboard. Note that text input is a native component that will open up the native iOS or Android keyboard, depending on the device you are using. This means that even with the same code, users may have slightly different experiences across platforms. It comes with many useful features such as autocorrection, placeholder text, support for different keyboard types, auto-capitalization, and many more. Now for the feedback form. Let's say you want to add 3 input boxes which are labeled first name, last name, and message. If you build these boxes with the text input component, it automatically enables the app to open up the device's virtual keyboard when the user taps on a box, a behavior that you don't need to write additional code for. This is a prime example of the native functionality that makes React Native stand out when it comes to building a seamless user experience. Let's examine the code used to create an input box. The text input component accepts several props, but let's focus on the ones that are present here. 3 of these props have basic purposes. The style prop is used to pass styles into text input, and placeholder is for adding any text that is displayed before the user types anything into the box. Value represents the value to show within the text input box. A bit more complicated is onChangeText, which is a method that is invoked when something is typed into the box. It's a callback, and the updated text is passed to the callback handler as a single string argument. The callback handler in this case is named onChangeFirstName. It defines a string and sets its state using a React state. Here, firstName is defined as an empty string, but when the user types something within the text input, the onChangeText will invoke this onChangeFirstName method and set the state of firstName with what has been typed in the text input box. In a similar way, you can define multiple text input components within a screen, associated with different variables such as first name, last name, and message, and set their respective states. In addition to the props from the last example, the text input component comes with several other useful props and features that allow you to further customize it for your specific use case. One of the more commonly used is the keyboard type prop. This is used to determine which type of keyboard will open when the user taps the text input box. Keyboard options include default, number pad, decimal pad, numeric, email address, phone pad, and some other platform-specific values as well. These different keyboard types enable you to better tailor input for specific use cases, such as entering phone numbers or email addresses. In this video, you have learned about text input, a core component of React Native, and how it can be used for inputting text into the app via a keyboard. You also got an idea of some example use cases for this component, such as can be applied toward creating a customer feedback form within the Little Lemon app. In this video, you'll learn how to configure a text input component to create a simple feedback form for your app. Previously, you learned that you can use React Native's text input component to create text input boxes. So, let's put that into action and create a feedback form for the Little Lemon mobile app. I've created a new component called Feedback Form, which does not yet have any functions, but it does contain a styles component that holds the styles I will be using in the form. The first thing I need to do is import the text input component, as this is the main component that I'll be using. Next, I'll write a return statement, inside of which I'll render a scroll view component. The feedback form will be inside of this component. I want a heading shown, so I'll write a text component to display the words, "How was your visit to Little Lemon?" and add some styling to it that comes from the styles component. I'll also apply some styling to the scroll view itself. I then want to place some informative text beneath the heading, so I'll do that with another text component and some different styling. I now have the basic layout set up, so let's start adding some text input boxes. The first one will be for the user to enter their first name. To create that, I'll add a text input component beneath the last text component and pass to it another existing style. This style is called Input in the Styles menu, and it defines such parameters as height, padding, font size, border color, and more. Next, I'll assign a value for the input box and also give it the prop onChangeText. The value will be first name, while onChangeText will be a method called onChangeFirstName. Neither of these variables have been created yet, so let's make that the next step. I'll start with the firstName variable. Keep in mind that I'll also use the useState hook to keep track of the local state here. So I'll add the method onChangeFirstName and then plug in the useState hook with an empty default state value. So what does this do? Well, firstName is the local state, but when the user starts typing in the first input box, it triggers the onChangeText method, which in turn calls the onChangeFirstName method. In other words, whatever is typed will become the new local state. To verify that the app works as expected, let's give it a try in the iOS emulator. So I have the header text, the informational text, and the text input box. When I click on the input box, it brings up the native iOS keyboard, and whatever I type appears in the box. Perfect! So now I'll add two more text boxes, one for the user's last name and one for inputting a message. These will be done in a similar manner as before, so I can copy and paste the firstName variable declaration twice, and then rename the variables and methods to lastName and onChangeLastName, and then message and onChangeMessage. Note that you can have an unlimited number of local states within the same component, so it's the best way to keep track of changes. In the scroll view component, I'll copy and paste the existing text input component twice, and then change the value and onChangeText props to correspond with my two new variables. So now I have three text inputs configured, one for the first name, one for the last name, and one for the message. And each one of them are tracked by the useState hook. Let's check these updates in an Android emulator this time. I have the header, info text, and three input boxes as expected. Clicking on a box pulls up the slightly different Android keyboard, but functionally the behavior is the same across all platforms. So I'll enter an example first name, last name, and a message. Let's type "Great," and that's it. Your form is complete and ready to use. In this video, you've learned how to configure a text input component to create a feedback form for the Little Lemon restaurant app. You made it an element of a scroll view component and also applied a useState hook for keeping track of local state. In this video, you'll observe how properties of the text input component can be used for handling the virtual keyboard. Specifically, you'll learn how to apply the keyboard dismiss mode and keyboard avoiding view properties. Let's recap what you've built in the Little Lemon mobile app so far. You have a feedback form containing three text input boxes, and when you click the one for first name, the virtual keyboard appears. With the keyboard on screen, let's say you want to scroll down the page a bit, but notice that the keyboard remains stuck in place. It would be nice for the user and also more intuitive if the keyboard were to disappear upon scrolling. Fortunately, React Native does have an option that makes that possible. Notice that the text input components are wrapped within the scroll view component, and scroll view has an interesting prop called keyboard dismiss mode. This prop determines whether the keyboard is dismissed in response to a drag. By default, the value is set to none, which means that dragging does not dismiss the keyboard. You also have onDrag, which causes the keyboard to disappear when a drag is started, and the iOS-only option, Interactive, in which the keyboard is dismissed interactively with a drag. For now, I choose onDrag by selecting it as the value for the keyboard dismiss mode keyword within the scroll view tag. Note that this will be applied to all text input components that are within this scroll view. Now let's go over to the emulator to check out this new property. I click on the first name box and enter a name, and then I scroll down the screen. The keyboard is dismissed as expected. Let's try the same thing for the last name box, and it gives the same outcome. This is a very useful property to use if you have a large form to fill out and don't want the keyboard getting in the way. Two more components I'll demonstrate are keyboard avoiding view and platform. To make these available, I first import both of them from React Native. Keyboard Avoiding View is a component that solves the common problem of views that need to move out of the way when the virtual keyboard is displayed. It can automatically adjust either its height position or the bottom padding based on the keyboard's height. I'm going to wrap the Keyboard Avoiding View as the main container view on top of the scroll view. I'm also going to move the styling that was given to the scroll view to the Keyboard Avoiding View instead. This component comes with a property called Behavior, and I set it for the emulator. Depending on the platform used, you can assign different behaviors using the Platform API that comes with React Native. When I assign the property a value of platform.os, React Native will know which platform the user is accessing the app from, whether it's iOS, Android, Windows, and so on. I'm going to add a conditional that says platform.os equals iOS, then the behavior is padding. If the platform is anything else, then the behavior is height. This setting is a recommendation from React Native, so that's what I'll use for this example. Finally, make sure to close the Keyboard Avoiding View tag beneath the Scroll View closing tag. So, the Keyboard Avoiding View component is useful when you have several text input fields on your page and don't want the keyboard to obscure your view of what is being typed into each one. Let's go back to the emulator to review the new changes to the Little Lemon app. I click the first name box and type a name. Then I press Return in the keyboard and click on the last name box. Notice that when the keyboard appears, the last name box is pushed up slightly so that it is completely visible. Previously, it was partially obscured by the keyboard. The same thing happens when I click on the message box. So what the Keyboard Avoiding View component does is push the rest of the view on the top. So you may miss some of the headers or other text inputs, but you will still have a full view of what you're typing, and that's what's important. Note that is how the app appears on iOS, but let's move over to an Android emulator to find how it differs. This time around, the appearance and behavior is slightly different. For example, there is more padding between the bottom of the focused text input box and the keyboard. Functionally, however, it is the same as the iOS version. Again, this component was introduced to solve the problem of views that need to move out while you're still typing in within your text input field. In this video, you learned how to use Keyboard Dismiss Mode to set behavior for dismissing the virtual keyboard when the user scrolls on the page, and how to use Keyboard Avoiding View to prevent the virtual keyboard from obstructing the user's view of text input boxes. In this video, you'll become familiar with a few of the properties of the text input component that can extend the functionality text input boxes in React Native. Earlier in the course, you created a basic feedback form for the Little Lemon app containing boxes for users to enter text. The next step is to explore the features of the text input component and learn how to pass properties to it. First, let's talk about the placeholder prop. The placeholder prop is used to fill the text box with placeholder text while it awaits input. The placeholder text can also help the user understand what the text box is for. For example, in the text box where the user should type their first name, I use the words first name as the placeholder text. Then, I use last name as the placeholder for the last name text box. And I use the instruction please leave feedback as the placeholder text for the feedback text box. Now let's examine the emulator. The first name placeholder is in the first box. The last name placeholder is in the second box. And the please leave feedback placeholder is in the third box. Once I start typing in this text box, you'll notice the placeholder text is replaced by what I'm typing. Another useful prop is the multi-line prop. So, when do you use it? If you don't think that the space you provided in the feedback text box is enough, then you can say multi-line equals true. Using this prop enables multiple lines in the text box that would otherwise not be allowed within text input. Let's bring up the emulator to examine how it works. I type a really long message until I reach the multi-line. And there you go. The multi-line message is displayed in the text input box. If I hadn't set this multi-line prop to true, then the message would have been cut off after the first line. So, if you have a form that requires a lot of characters in some input boxes, then you can set the multi-line prop to true to allow for multiple lines. If you want to restrict the number of characters entered in the text box, then you can use another prop named maxLengthProp. With this prop, I can set the maximum number of characters. And using this prop instead of implementing the logic in JavaScript is great because you can avoid any kind of flicker. Let's say 250 characters is the maximum number of characters the user can enter into the feedback text box. Now, let's move on to the next prop. If you were designing a login page, it would have to have a password field. For fields like that, you can use the secure text entry prop to obscure sensitive text like passwords. The default value is false. But if you want to, you can hide this information by using this prop, right? Let's apply this to the first name text box just for demonstration purposes. If I say secure text entry equals true, you'll notice that what I'm typing is not visible, and that's how a password field works. For now, I'm going to remove this property because I don't actually want to hide the user's first name. Text input also supports a prop to add a keyboard type. By default, I've used the regular keyboard type thus far, but what if you want to use numbers as input? I'm going to add a text input for a phone number. I also make sure to add the state for the phone number keyboard type. Because I want to input a phone number, I add PhonePad, which is a keyboard type that works in both iOS and Android. Let's examine the emulator to determine how it displays on iOS. You can note the additional phone number text box I just added. And by clicking on it, I open the PhonePad so that I can enter numbers instead of letters. This is the native iOS PhonePad. If you were to switch to the other text boxes, you'll see that the keyboard immediately changes. So for first and last name, you have the standard keyboard, and for the phone number, you have the PhonePad. Now let's examine the Android display. This is the native PhonePad for Android devices. You can type in any number you want. Very convenient. Keep in mind that all of these are native components, which is why React Native is such a good choice, because you don't have to work in the native code. Instead, you directly use these native components that come with the React Native package. The properties I demonstrated in this video are not the only ones you can use. There are plenty of other props that you can pass to text input, like autofocus, autocorrect, and autocompletion. It all depends on what you need. So there you have it. You've become familiar with a few ways you can customize your feedback form in the Little Lemon app to create a more refined experience. In this video, you learned how to use the following properties: placeholder, multiline, max length, secure text entry, and keyboard type. Which properties you choose to use depends on your use case, and you can turn them on or off based on what your use case is. In this video, you'll become familiar with how to use some of the common methods that come with the text input component. The first method you'll observe is the onFocus method, and I'll start by adding it to my existing text input component. This property is a callback method that is called when the text input is focused. The feedback form has input boxes for first name, last name, and a message, and I want an alert to be displayed when the first name box is in focus. In order to demonstrate this, I'll import a new component that you haven't encountered before, which is the alert component. You don't need to understand this component at this point, as I'm just using it to illustrate a use case for onFocus. So in the text input component for first name, I'll pass a function to onFocus that will display an alert on screen anytime the first name box is in focus. To do this, I'll use the alert method that comes from the Alert API and set the message first name is focused to be displayed. Next, let's open the app in the emulator to verify what this method does. Sure enough, when I click on the first name box, a message pops up with the text first name is focused. So the onFocus method in text input was called automatically when I clicked the box, and I can now click on OK to dismiss the alert and continue typing into the input box. The next method from the text input component that you'll become familiar with is the onBlur method. This is also a callback, and it's called when the text input is blurred. What this means is that once the focus is taken away from a text input field, the onBlur method is automatically called. As I did with onFocus, let's use onBlur in the text input for first name to call an alert. This time, the alert will appear when the first name text box is blurred. So I'll use the Alert API and set the message as first name is now blurred. Again, let's check the updates in the emulator. I'll click on the first name box to trigger the onFocus message and then dismiss it. Then I'll type some text into the box and press the return key in the keyboard, which then causes the message, first name is blurred, to pop up. This occurs because the first name box is no longer in focus, causing the onBlur method to be called. So now you've observed a couple of examples showing how the onFocus and onBlur methods work. Now let's explore a few other useful features of the text input component. At some point, you've probably typed some text into an input box incorrectly. You want to click on one button to clear it all out. But right now, you'd have to hit backspace multiple times to clear things out. Wouldn't it be nice to have a clear button that could get rid of everything in one go? You'll probably be glad to know that React Native supports such a feature. The text input component has a prop called Clear Button Mode. This prop is an enum and determines when the clear button should appear on the right side of the text box. Recall that enums, or enumerations, are a data type with a fixed set of values. In this case, those values are never, while editing, unless editing, and always. For this example, I'll add Clear Button Mode for first name, declare always so that the clear button is always present. I'll then copy this line and paste it to the text input for the last name and message boxes to achieve the same effect. Keep in mind that the Clear Button Mode is only available on iOS, and the default value for this is never. To add the same feature for Android, you will need to write your own implementation or use a library that provides this functionality. Another small quirk to note is that the Clear Button Mode does not work if you have a multi-line text input. Because the message box has multi-line set to true, I'll change it to false, so that Clear Button Mode will work correctly and display the clear button. It's time to check the app in the emulator again. This time I'll click on the last name box and type some text before pressing the return key. A small button with an X then appears on the right side of the last name. I didn't even have to design the button or design the clicks. I got it simply by using a built-in prop. When I click on the button, it disappears. The text is cleared and the keyboard pops back up so that I can type something else. If I click on the message box and type some text there, the clear button will appear there as well. Notice this time that the button is vertically centered in the box, due to the styling that was applied. Let's finish off by typing something in the first name box, and sure enough, I get the clear button there as well. In this video, you learned how to use the onFocus method to trigger a response to a text input box being focused, use the onBlur method to trigger a response to a text input box being blurred, and use the Clear Button Mode method to configure a button for clearing a text input box. You're now ready to create forms in React Native that offer a more intuitive text input experience for users. Well done. So far, you have learned about some of the basic components of React Native, such as those for adding text, scrollable views, and text input boxes. But what if you want to let your user interact physically with the app? With React Native, you can add interactivity using the pressable component. In this video, you will learn about the pressable component from React Native, which is used to detect the user's press interactions. The current build of the Little Lemon app uses text to express important information, such as the restaurant name and the menu items on offer. In this sense, it's complete, but it's not very exciting, is it? But don't worry, as Adrian has a new request for you. He wants you to add more components that can enhance the experience and make it more interactive. One way you can do this would be to apply the pressable component in the app. Pressable is a core component from React Native, which was only recently added to the library. It can detect various stages of press interactions from the user, including on any child components. Looking at Adrian's request, he would like to include components that allow users to take actions, such as pressing buttons. The pressable component is wrapped around its child elements, which then become pressable by the user. Let's explore a code snippet that demonstrates the basic syntax of the pressable component. Notice that the pressable component wraps around the child component, which is a text component in this case. In the app, this makes the text component something that can be pressed. So how does this work? The pressable component is a well-thought-out component created by React Native. It comes with a few inbuilt methods, so let's observe two of the most important ones. First, you have the onPressIn method, which is called when a press is activated. This is as soon as the user's finger presses an element wrapped by the pressable component. Then, the onPressOut method is called when the press gesture is deactivated, or when the user's finger moves away from the pressable element. Note that timing affects how the pressable component behaves. If the user leaves their finger longer than 500 milliseconds before removing it, another method called the onLongPress is triggered. In fact, React Native allows you to customize this time period using the delay-long-press prop. Isn't this cool? You can now distinguish between regular press and long press using the pressable component. With the pressable component, you can design the pressable area, which are the child components. So you now know a bit about how a pressable component works behind the scenes. But what does a user actually encounter in the app? Your initial thought is probably a button, but pressable elements can actually be represented in several different ways. Depending on the specific use case, it could be a button, some text, an icon, or anything else. So, the look and feel of what is pressable are entirely up to you. For the Little Lemon app, Adrian wants you to add a button that allows the user to access the menu. Let's find out how the code for that might be written. The code will have a pressable component that wraps a text child component with the text View menu. The pressable component also takes in some styling that comes from a style sheet. The style used in this case is called button. This style results in a button with a green background and white text. Also, notice that the onPress method has been defined. This means that when the user presses the View menu button, it invokes the onPress method, which sets the show menu state to true. Developers often use this pattern where a local state of the component is updated after pressing a button or pressable area. Button clicks, user interaction, inputting text, and so on, are local to a React component. As such, typically these actions and their state are stored locally within the React component. In the Little Lemon app, when the user clicks on View menu, the local state of Show menu is set to true. You can then use this local state to keep track of whether to hide or show the menu on the screen. You'll explore exactly how to do this later in the lesson. Before ending this video, let's get familiar with one more feature of the pressable component that has usability in mind. If you've ever aimed for one button in a mobile app but mistakenly pressed another, you'll appreciate HitRect. HitRect is an optional feature of the pressable component that you can use to define how far from the wrapped element that a touch is registered. Fingers are not always precise, especially on smaller screens, so it's a nice option to have. Pressable is a complete component that detects various stages of press interactions and provides thoughtful consideration on pressable areas. In this video, you have learned what the pressable component is and its basic functionality. Now you can work on designing some screens within the Little Lemon app that utilize the pressable component for users' press interactions. In this video, you'll find out how to use a pressable component in a React Native app. You'll also learn how to use the onPress method to determine what happens when a pressable is activated, and the useStateHook to track local state. Before I add a pressable component, let's recap what I already have in the menu component of my Little Lemon app. There is a list of menu items, along with section headers for each grouping of items. Now, what I want to add is a button on the home screen that reads View menu. Clicking on this button will then make this menu appear. Additionally, I want some text displayed on screen when the View menu button has not been clicked yet. So now, let's go back to my code for the app to get this done. To add a button, I first need to import the pressable component from React Native. In the View, I then add a new text component that contains some introductory text for the restaurant, and also prompts the user to view the menu. I also apply a style to the text. I want to place the button right below this text, so I start a pressable component beneath the text component and add a predefined style to it. Next, I add the onPress property to the pressable, which is a callback function that will be triggered the moment the user clicks on the pressable area. I don't have a callback function written yet, so I'll leave the property value blank for now. Within the pressable area, I want to display the text View menu, so let's place another text component within the pressable to add and style that text. Note that because the pressable wraps this new text component, everything within the View menu text is pressable. The next thing I need to do is define local state for the View menu button click. This is because I want to keep track of whether or not the user has clicked the button, and once they have done so, a second click will close the menu. To do this, I define a local state and call it showMenu, and the setup function for it will be setShowMenu. Here I use the useStateHook, which returns the local state. The default value for showMenu will be false, in which case the menu will be hidden. When the user clicks the View menu button, the menu will appear. To make this possible, I need to add the callback within the onPress method. In the method, I call setShowMenu and send the Boolean value from showMenu and toggle it. So if it's true, then it becomes false, and if it's false, it becomes true. So now I have a pressable component with an onPress method that toggles the local state and some text that reads View menu. Now I also want the text to be a little smart, in that if a user has clicked the View menu button and is already viewing the menu, the button text will instead change to Home, and clicking on it will send them to the home screen. Let's find out how to do that. So I alter my text component a bit by adding a conditional operator. The condition states that if the value of showMenu is true, then display the text Home. If the value is false, then display the text View menu. This will all happen within the same button. Now I also need to tweak my section list component to ensure that the menu it contains will only appear when showMenu is true. So again, I add an operator here that only renders the section list when showMenu is true. In other words, if the user clicks on View menu, they'll get a menu, and if they click on Home, then the menu disappears. I also want to add a similar tweak to the introductory text that I added earlier. So in front of that text component, I type !showMenu and a double ampersand for the logical AND operator. Okay, we're almost there. Let's review the styling that I've applied to the pressable and to the text component. In my style sheet, I have a style called Button that sets the font size, padding, and a few other common parameters. I've also added a style called Button Text that sets color, alignment, and font size. All right, are you ready to check out the result of these updates? So I have the introductory text and a button that reads View menu. Note that I'm not using a true button component, but rather I've styled and defined a pressable component to function like one. I click on the button and it removes the introductory text to display the menu instead. The button has moved up and the text has changed to read Home. So behind the scenes, my click changed the showMenu value to true and triggered the onPress method. When I click the button again, the screen reverts to what it was previously, as showMenu has been toggled back to false. In this video, you went through an example use case of the pressable component. You also used the onPress method to trigger an outcome for clicking the pressable area and the useStateHook to track local state. I hope you're feeling excited about the possibilities of building an app in React Native. At this stage, you should be familiar with adding components, but you can also add images to an app. Adrian is quite excited about what you have built so far with the Little Lemon app using React Native. The app has headers, lists, text input boxes, and a few buttons. However, it's still lacking visually. To change that, he would like you to include the Little Lemon logo to the app along with some other images. Let's find out how to add image components and see if you can use this knowledge to help Adrian. In this video, you will learn about the image component in React Native, which will enable you to add images and style them within your React Native app. You'll also learn about the types of images you can add and where they can be stored. The image component is a core React Native component that is used for displaying different types of images. You can use the image component to display static images from resources, temporary local images, images from a local disk such as the camera roll, and network images. To demonstrate how to use the image component, let's help Adrian display the Little Lemon logo within the mobile app. Now, how do you get started? The first step would be to import this image into your React Native project. If you don't already have one, you'll need to create an IMG folder within your React Native project source folder. Within this IMG folder, add all the images that you would like to display in your app. Make sure to provide each file with a meaningful name so it is easy to reference them in the future. With the image files in place, let's now check out some code that will make the logo image appear on the app's welcome page, along with a bit of text. Notice that the image component goes inside of the view. It has been given some styling, and you can pass the image information using the source prop. To the source, you can pass the location of the image, which is ./img/littlelemonlogo.png. While the page is rendered, the image component loads this image file and renders it with the style that was passed to it. The styling applied to this image came from a style sheet and sets the height and width of the image. But there is also a new prop here called Resize Mode, which determines how to resize the image when the frame doesn't match the image's dimensions. For example, when Resize Mode is set to Contain, the image will be scaled uniformly so that its dimensions will be equal to or less than the corresponding dimensions of the view, minus the padding. Some other options that can be given to the Resize Mode are Stretch, which allows width and height to scale independent from each other, Repeat, which repeats the image to cover the frame of the view, Cover, which scales at least one dimension to equal that of the view, and Center, which centers the image in the view. If you check the app, you'll find that the logo is rendered to the specifications of the styling, and the text is also displayed. Wow, the Little Lemon logo displays perfectly on the mobile device, and I am sure Adrian is going to be excited about this. In addition to local files, you can also render images from the internet within your mobile app. To do this, you can pass the Uniform Resource Identifier, or URI, to the image component's source prop. For example, instead of a file path as provided in the previous example, this time you can enter the URI for the network location in which the image is hosted. In this case, the code retrieves an image from the React Native website. The image component also provides a prop named Loading Indicator Source, which represents the resource that is used to render the loading indicator for an image. This loading indicator that you provide will be displayed until the image is downloaded from the network URI and ready to render. This gives the user an indication that something is about to load. React Native supports many image formats such as PNG, JPEG, GIF, and WebP. These are supported for both iOS and Android. In addition, there is iOS support for PSD, RAW, and several other uncompressed image formats, which are not available for Android. This is very useful for applying images of the highest possible resolution. In this video, you have learned about the image component in React Native that is used to display images within the mobile app. You now understand that both local and network images can be displayed using the image component, and the images can be styled based on the user's needs. Good work! In this video, you'll find out how to use the image component to place an image in a React Native app. I have a welcome page for the Little Lemon app with some text at the top that reads, "Little Lemon, your local Mediterranean bistro." It's not too exciting, so I want to add the Little Lemon logo to it as well, which I'll do by using the image component. Let's find out how to do that. Inside the project folder, I've created a folder called Image, and in here I've uploaded the Little Lemon logo image as a PNG file. This is the logo that I want to display on the welcome page. I'll need to place the image component within the welcome component that I created previously, but before doing that, I'll import the image component from React Native. In the view of the welcome component, I'll place the image component above the text. I'll next need to define the source, which is the location of the image. I'll use the require keyword, and then within double quotes, I'll type the destination file path. So I type img/littlelemonlogo.png and then close the image tag. And with that, the Little Lemon logo is ready to be rendered. So with the image component that is built into React Native, all I need to do is to pass a location to the source prop. This prop can also take remote URLs with a container that has pre-specified dimensions, but in my case, the file destination is good enough. Now let's go to the emulator to check out the updated welcome screen. You'll find that the logo appears above the welcome text. However, it's larger than it should be, and part of the image is actually missing. To fix this, you'll need to apply some image styling, which you'll learn how to do next. In this video, you learned how to add a logo image to your React Native app by using the image component and specifying the image location. Previously, I added an image of the Little Lemon logo to the mobile app. However, it wasn't styled accurately. In this video, you are going to learn how to style the image accurately. Before I proceed, let me recount the current status of my app. It contains an image component that holds the Little Lemon logo and a text component that renders the text, "Little Lemon, your local Mediterranean bistro." Both of these reside within a view component. I also have a style sheet component that contains various styles so that I can easily apply them to the different elements of the app. In my style sheet, I create a new style called Logo. The style will specify a height of 100 pixels and a width of 300 pixels for the logo. The logo style is ready, and I'm going to pass that style to the image component as a prop. So I'm passing the style prop, and I'm calling it styles.logo. The style is now ready. Now, how does the styling with a basic height and width display on the emulator? On the emulator, the edges on the sides of the logo have been cut off. How do I fix this? I have a solution. I can pass the resize mode prop to an image component. The resize mode determines how to resize the image when the frame doesn't match the raw image dimensions. React Native comes with several options for the resize mode. I can now give the resize mode prop a value of cover, contain, stretch, repeat, or center. If I select cover, it will scale the image uniformly so that both dimensions, the width and the height of the image, will be equal to or larger than the corresponding dimension of the view. If I select contain, it will scale the image uniformly so that both the dimensions, the width and the height of the image, will be equal to or less than the corresponding dimension of the view. With stretch, I can scale the width and height independently. Repeat is where I can keep repeating the same image to fit the frame. And lastly, center is where you center the image. For my purpose, I'm applying the resize mode as contain. I want to scale the image uniformly so that both dimensions of the image will be equal to or less than the corresponding dimension of the view. That is it. I have styled the image. I have applied a style prop, and I have also given it the resize mode value of contain. So how does the styling now display on the emulator? That is way better. The Little Lemon logo displays perfectly. It now has a specific height and width set up in addition to the resize mode. That ensures that the logo is contained within the frame given to it. I am curious about how the logo will display on an Android device, so let's check out the app in an Android emulator. The logo displays crisp and clean on the Android emulator as well. This means that the code works cross-platform for both iOS and Android. The little lemon logo is all set and displays beautifully on the welcome page. In this video, you have learned how to style an image. Now go and practice. So far, you've learned how to use the image component within your React Native app. And I've included the little lemon logo as an image within the welcome screen. You also learned how to style it with the basic features. In this video, you are going to learn a little bit more about the image component. Specifically, you'll find out how to pass in props for adding accessibility features to your images. It's important to ensure that apps are accessible for visually impaired users by making elements compatible with assistive technologies such as screen readers. In the case of Little Lemon, I want to make all images identifiable as pictures of menu items. Now, the first thing I'm going to do is update the view container to a scroll view container. I need this because I'm going to have a taller page which is scrollable. I need to make sure that the scroll view component is imported. Notice in the image folder that I've imported more images. Picture 1, 2, 3, and 4. I want to display these pictures within the Little Lemon app's welcome page. Now, within the welcome page, take note of an important prop that needs to be passed to the image component. It is called the accessible prop. The accessible prop is a Boolean. When the Boolean is true, it indicates that the image is an accessibility element. Such elements can then be interacted with by assistive technologies. This is a prop that you can include as long as you're giving labels to your images. So once I set this to true, I make sure to fill in the accessibility label prop. I'm labeling it as something descriptive. In this case, it's going to be a Little Lemon logo. Now, once you have this label defined, this is what the screen reader will display when the user interacts with this image. So make sure to keep accessibility in mind when you're adding components in React Native. It doesn't have to be just an image. You can use these for other components as well. All right, now I'm including additional images within the welcome component here. So let me continue to copy-paste. I update the file name to picture1.png. In a similar way, I include the other pictures as well, but I'm going to style it differently. I use styles.image, which will have a bigger height and width for this image as displayed on the emulator. I repeat the same steps and include some more images. I want these images below the welcome text. So I've moved it down below the welcome text, and I'll simply copy-paste the same component a few more times and update the file names. I do that to picture 2, 3, and 4. Perfect. All these 4 different images are now displayed below the welcome text, and they're styled differently than the logo. They are also scrollable. I now need to update the accessibility labels. Because I pasted the label from the Little Lemon logo, I need to change each one to match the image it is associated with. So I name the first image Food Picture 1, the second image Food Picture 2, and so on. When you're designing real apps, make sure to give more meaningful names which actually describes that food. The more descriptive you are, the better it is for accessibility. So I've given unique labels and the app is now ready. All 4 images display under the logo. What other styling options can I include within the image component? I'm going to add and customize a border. I include a border width of 10 pixels. Notice how different this image displays on the emulator. Once you included this border width, it changes the entire way the image component displayed and rendered. The border comes with a default border color of black, and this is something you can always change. I'm going to decrease this border width to 2 because 10 seems like a lot. You can change the color of the border to any color required. I'm changing the color to red. The emulator now displays a thinner border width in red. You can also provide a border radius to your image component and basically play around with your styling and choose what best suits your requirements. Let's say you want this image to fill this entire box. Change the resize mode prop to cover instead of contain, and that would spread out the image cover to cover, picking up all the space. You can also get rid of the border if you don't like it. Once you've removed all these border widths and border colors, it displays cleaner. If you're interested to check out how the images are rendered when you change to different resize mode options, such as repeat, you can check the result on the emulator. Now, the images are repeated in a tiling format. This could be a design requirement from a mobile app perspective, so keep in mind that you can do all kinds of design techniques and styling with your image component, and the styling options support these various rendering methods. You have now learned about the image component. Specifically, you now know how to pass in props for adding accessibility features to your images and applying some styling options. And with that, you are in a good spot to now render images within your React Native app and to be able to efficiently style them as well. So far, you've learned how to render images within the React Native app. But what if you want to add an image that you can then render other components on top of? React Native has you covered. In this video, you are going to learn how to render a background image within the React Native app. Using of a background image is standard practice, and you will encounter this request many times. To make this possible, React Native has come up with a component called the Image Background component that you can utilize to display background images. In the image folder, I have added the image called the littlelemonbackground.png. I want this image as a background image for one of my screens. Now, how do I achieve that? I go back to the code for the welcome screen that displays the welcome text. I now want to render a background image. Before I start, I import the image background component. Keep in mind that the properties are very similar to the image component, except that this renders the image as a background image. That implies that you can have text and other content on top of it. I'm passing the source just like I would pass the source to the image component, to the image background. I'm using the require function to get to the background image. I then need to specify the image file and its location. Recall that the file is stored in the image folder and is called littlelemonbackground.png. And I'm closing the tag after the curly braces, and I also want to make sure that I close the entire background image tag here. What this means is the image background is essentially wrapping this welcome text. The welcome text will thus be on top of this background image. I also want to create some styles for this image. In my style sheet, I create a new style called image. In the style, I give it a flex property of 1, which means I want the background image to occupy the entire space of the screen. I also want to add justify content to center, which means everything that is displayed within this image background component will be within the center, and that's it. To the image background, I'm passing the style prop and I'm going to apply styles.image. Keep in mind that the resize mode property is also applicable to the image background, so let's use that as well. I give the resize mode the value of contain, just like I did with the images. That means it's going to contain the image within the screen space that I have available. The styling is done. I've given the resize mode property and I've given the source for this background image. And this image background component is going to wrap the welcome text. So how does this display on the emulator? On the Android emulator, the correct background image for Little Lemon displays perfectly on the entire page. Notice the welcome text in the middle of the screen. This is what I planned and why I gave the styling of justify content to center. It is also displayed on top of the image background. In this video, you have learned how to render a background image within the React Native app. Anytime you need a background image for your page, make sure to use the image background component. So far, you have learned about several core components for adding and creating content in React Native. However, bear in mind that if you have components that utilize state, it can be easy to lose track of state changes if you're not careful. Fortunately, there is something you can use to make this easier, and it's something you may already have some familiarity with. In this video, you will revisit the concept of hooks. In the Little Lemon app, local state is kept in several of the components, such as the text input. Because there are several such components, Adrian wants you to make sure to manage these carefully. One way you could do this is through the use of hooks. Recall that hooks are functions that let you hook into React state and lifecycle features from components. You previously explored how the useStateHook can help you keep track of state in React, but let's revisit it before you find out how to apply it in a practical way. Later in the course, you'll also learn about other hooks which can make development more efficient as you continue with your Little Lemon app. Remember that the useState hook is used to manage the state within a component and keep track of it. Let's recap the key steps involved in utilizing a useState hook. The first thing you need to do is import the useState from React. The next step is to declare a state variable within a component. Here you have a new state variable called showMenu, and the useState sets the initial value of showMenu as false. Calling useState does two things. It creates a state variable with an initial value that represents the current state, which in this example is showMenu, and it creates a function to set that state variable's value, which in this case is setShowMenu. The function setShowMenu is used to update the value of showMenu by passing a Boolean value to it. It doesn't matter what names you use. They are all defined by you based on your component and use case. In the example, the useState hook was used to track a Boolean state value, but you can use the useState hook to track any kind of data. The data could be presented as strings, numbers, arrays, or it can be Booleans or objects. In addition to the hooks that are built into React, you can also build your own hooks, which will let you extract custom component logic into reusable functions. This is an excellent feature and benefit of using hooks. However, the biggest benefit of hooks overall is the readability and simplicity that they provide for your code. In this video, you revisited React hooks and found out how they can be used to extend the functionality of components in your React Native apps. Next, you'll explore some specific hooks that you might find particularly useful for your Little Lemon app. In this video, you'll learn how to use a built-in hook in React Native called useColorScheme. This hook provides and subscribes to color scheme updates from the Appearance module in React Native. So what exactly does that mean? Well, a practical use for useColorScheme is that it can apply styling changes in the app based on whether the user's device is set to light theme or dark theme. It can also detect when the setting changes and adjust accordingly. For example, if a user's device is set to automatically change from light to dark theme at a certain time of night, and this happens while the user is using the app, then useColorScheme could be set to kick in and update the app's theme to match. Pretty useful, right? So, let's apply the useColorScheme in the Little Lemon app to do just that. The first step to take would be to import useColorScheme from the React Native package. Within the component where you plan to use this hook, you'll then need to instantiate ColorScheme as an object and plug in the useColorScheme hook. The hook can return 3 possible color theme options, which are light, dark, or null. Null is returned when the user has not indicated a preferred color theme. To help clarify the changes that will happen in the app, I will add a text component that prints the value of the color scheme object. This would not serve any useful purpose in a real app, but I am including it for demonstration purposes. To set up my themes, I'll first make an adjustment to the style that is applied to the scroll view component. So in the style sheet, I scroll down to Container and remove the background color. Next, in the scroll view, I pass an array of styles, rather than just a single one. I do this by enclosing the styles within square brackets. In addition to the container style, I also pass in color scheme. This means that the scroll view will first take in the container style, and since container no longer has a value for background color, it will get a background color from whatever is set for color scheme. Now I have to set up the logic for color scheme. If the color scheme is light, then I want to display a white background. If it is dark, then it should have a dark gray background. So how can I write this? For color scheme, I type a strict equality operator, or triple equals, and then a value of light. I then set up a conditional, which states that if this value is true, then the background color will be white. Otherwise, the background color will be dark gray. Otherwise here implies that color scheme will be dark or null. So this is how you can pass an array of styles that uses both a pre-existing style and a variable style in the form of the useColorScheme hook. Note, in a real app, you would most likely apply Use Color Scheme to adjust the color theme at an app level, rather than an individual page level as I did here. Now, let's check out how my adjustments show up in the emulator. Currently, you'll find that the page displays a white background, along with the text Color Scheme Light. This indicates that the device theme is set to light. To demonstrate that the Use Color Scheme hook works, I go into the emulator settings, Developer Options, and then toggle on the switch for Dark Appearance, which changes the entire emulator into dark mode. Now when I go back into the Little Lemon app, the changes are immediately visible. The background is dark grey, and the text reads Color Scheme Dark. In this video, you learned how to use the Use Color Scheme hook to enable your React Native app to update a color scheme automatically based on the color theme of the user's device. In this video, you will learn about the Use Window Dimensions hook. This hook is used in React Native to automatically retrieve information about the window's height and width values, as well as the font scale. In practical use, this information can help you determine how your app elements appear on windows of different sizes and make more informed decisions on how to adjust their size and scale. The first step is to import the Use Window Dimensions from the React Native package. Now, how can I use this? Just like any other hook, Use Window Dimensions can be used within a React component. So, I have const here, and what I'm going to get from the hook are the height, width, and the font scale. Font scale is the scale of the font that's currently used within the app. Some operating systems allow users to make the font size larger or smaller for reading comfort. And that's it. Now I can start using this height, width, and font scale within my app. And I can use the hook for different calculations. The height, width, and font scale are all numbers, and they've been destructured from the Use Window Dimensions hook. What's useful about this hook is that you can get the updated value of the height, width, and font scale whenever the screen dimensions change. Let me print out the window dimensions on screen, such as height, width, and font scale, so I have that information. I include text here, and I style it with styles.regular, which I've already defined in the style sheet. In the text component, I type window dimensions. I'll then copy and paste the same text component 3 more times, but I'll change the text to be printed in each one. So I've already destructured all the values I need from the hook. Now I want to display the height. Then I want to display the width. And lastly, I want to display the font scale. Now I have everything I need. Let's examine the iOS emulator to see what the Use Window Dimensions hook has returned. There's the window dimensions displayed for the iOS emulator. It's 844 by 390 and a font scale of 1. I can add text within the text component to say that the height is 844 and the width is 390, and the font scale is regular, which is 1. Now let's examine the Android emulator. The values are different here. The height is 712, the width is 360, and the font scale is 1. This video has demonstrated how to use the Window Dimensions hook to obtain the latest dimensions of the screen and the font scale, which can help you make design decisions. So by now, you've become familiar with a few of the hooks that are built into React Native, including Use State, Use Color Scheme, and Use Window Dimensions. However, remember that React Native is open source, meaning that the developer community can contribute new hooks and extend React Native's capabilities even further. In this video, you'll explore some community hooks and find out how to access them. So just like there are community components outside of the core React Native package, the community also has made hooks that you can plug into your application. To access them, you first need to access the web page at github.com/reactnative-community/hooks, or use the link found in the additional resources. To get these hooks, you'll need to scroll down to the installation instructions and run either an npm or yarn install on the @react-native-community/hooks package into your application. This package contains 12 hooks at present, but the community is constantly improving them or adding more. Let's examine a few which might be useful for your application. The most frequently used community hook is Use App State. This hook tells you whether the user has your app in active or background mode, or also inactive in the case of iOS. This allows you to customize app behaviors based on the status. For example, you might want to disable certain functionalities when the app is in background or inactive in order to reduce power consumption of the user's device. Another great hook is the Image Dimensions hook. For this one, when you pass in the source of an image, whether it is from your assets or a web URL, it returns the dimensions of that image. As a bonus, it will also tell you if an image is loading or if it has run into an error. So with the Image Dimensions hook, you can use the data about the height, width, and aspect ratio of an image to inform the design of your application. Another common hook is Use Keyboard. This one simply tells you if the virtual keyboard is displayed on screen or not, as well as its height. This can help you design your app to utilize the keyboard more effectively. And finally, one more hook to discuss is the Use Device Orientation hook. This hook tells you whether the user has their device in landscape mode or in portrait mode. This is especially useful when the user's mobile device is a tablet, and it also helps you if your app can respond to landscape versus portrait mode design considerations. Keep in mind that to be able to install this Community Hooks package, you'll need to have React Native version 0.59.0 or higher installed. In this video, you learned about React Community Hooks and how to install them. You also explored some of the more common hooks and found out why they might be useful for your React Native application. Well done! You've reached the end of the Pressable, Images, and Hooks in React Native module. Let's take a few moments to review what you learned during this module. You began the module with an explanation of how users can interact with an app. Now that you've completed this lesson, you can explain what a pressable component is, identify common methods of pressable, such as onPressIn and onPressOut, and explain that a pressable component can be represented in different ways, such as text or an image. You should also know how to create a pressable component that responds to a user press and use the useState hook to track the state of a pressable. You then moved on to the next lesson where you learned about the image component in React Native. Having completed this lesson, you can now explain what the image component is, identify where images can be sourced from, and identify which image formats are supported. You also gained the ability to create an image component in your React Native app and style the images contained in an image component. You then undertook the third lesson in this module, where you went in depth into hooks in React Native. Following this lesson, you should now be able to describe situations in which hooks are useful and describe the basic coding structure for applying a hook in a component. You should also know how and when to make use of several common hooks, namely the Use Color Scheme hook, the Use Windows Dimensions hook, and several community hooks created by the React Native developer community. You're now familiar with pressable, images, and hooks in React Native. You had some coding exercises where you practiced using the functions. You should be able to apply all these new skills in the Little Lemon app. The Little Lemon app is slowly taking shape. You've created several screens, and now Adrian would like to add the ability to move or navigate between them. How will you achieve that? In this video, you will learn what React Navigation is and how it can be used to transition between screens in React Native. You'll also come to understand in what ways it is beneficial, as well as some of the trade-offs you might encounter. Moving between screens is referred to as navigation or routing in mobile apps. Mobile apps have multiple screens, and the user's experience relies on smooth navigation between these screens. React Native does not have inbuilt navigation. All React Native developers must pick a navigation library to implement moving between the screens in the app. This is where React Navigation comes onto the scene. React Navigation is the most popular navigation library for React Native apps today. It is easy to use, customizable based on your needs, and has platform-specific components for both iOS and Android. It can be used for both React Native CLI apps and React Native apps built with Expo. React Navigation is an open-source library that is trusted by the community. It provides a native stack navigator that can transition between screens and manage the navigation history. You need this navigation history for when the user decides to go back to the previous screens. As a React Native developer, you don't need to worry or learn about how this navigation works and how it maintains history. All of it comes built in with React Navigation, and you will simply use the React Navigation API for your use case. A big difference between how routing or navigation works in web browsers versus React Navigation for mobile apps is that React Navigation provides the gestures and animations that you would expect on iOS and Android devices. For example, in a web browser, let's say you click a link that takes you to a new page. When you press the back button, the browser pops the page from the top of the history stack and you return to the previous page. React Native doesn't have such an idea built in, but that's where React Navigation provides a way to move between screens and manage history. React Navigation may use native libraries to implement some animations and gestures. These libraries include Screens, which provide native navigation container components, and Gesture Handler, which makes React Native more compatible with native touch and gesture systems. Many of the UI components are written in JavaScript on top of React Native primitives. Because of all this, it is easier to push over-the-air updates, which are updates sent to a device wirelessly, easier to debug the code, and it is also possible to customize the navigator components. React Navigation comes with built-in navigators such as Stack, Tab, and Drawer, each of which you'll explore in more detail later. However, you should know that it is possible to write your own navigators and customize them with the exact look and feel that you want in your app. In fact, you can create these custom navigators without having to write any native code. React Navigation provides navigators written fully with JavaScript, and navigators are implemented on top of platform navigation. This means you can pick the navigators suitable for your use case. So far, you've heard all the good things about React Navigation. While exploring a new library, it's always good to also understand what the trade-offs are. So, what are the trade-offs with using React Navigation? Some of the navigators don't directly use the native navigation APIs on iOS and Android. This has been done as a conscious choice to make it possible for developers to customize the navigation experience. This means that if you want the user's navigation experience to match the native iOS or Android experience, then you'll have to stick with the native stack navigator and not use the other navigators that come with React Navigation. Another trade-off that you may notice from time to time are breaking changes when you upgrade from one version to another version of the API. In other words, while gaining access to new features after upgrading is generally good news, it's possible that code using older APIs will no longer work as expected. If you decide to go with an alternative navigation library, you can choose from two other commonly used libraries: React Native Router Flux and React Native Navigation. When developing the Little Lemon app, you will make use of the React Navigation library. In this video, you have learned what React Navigation is and how it can be used to transition between screens in mobile apps. And you also understand its benefits and trade-offs. You are now ready to explore and learn more about React Navigation. Are you ready to start navigating through your app? In this video, you'll learn how to set up React Navigation within your React Native apps. If you select the Read Docs button, it will take you to React Navigation's official documentation. Notice that they have a Getting Started section. Here you'll find what you need before getting started. So what are the minimum requirements that you need to have to set up React Navigation? You need to be using at least version 0.63 of React Native or higher. If you're using Expo, it needs to be at least version 41 or higher. Expo and TypeScript are also both compatible with React Navigation. Expo is a platform for mobile app development, and TypeScript is a JavaScript-based programming language that also supports certain React and React Native libraries. If you're using TypeScript along with React Native, it needs to be version 4.1.0 or higher to install React Navigation. If your setup meets the requirements, let's go ahead and start the installation process for React Navigation. The first step is to run the command npm install at react-navigation/native. This is going to install the core utilities that are used for setting up the navigators. In addition to this, you also need some libraries that React Navigation depends upon. If you're installing it with an Expo project, you need to run the command npx expo install react-native-screens react-native-safe-area-context. This will let you install React Native screens and React Native safe area context within your Expo project. If you're running it within a barebone React Native project, then you can directly do an npm install by typing the command npm install react-native-screens react-native-safe-area-context. And that's all you need. Once you have these basic items installed, you're ready to get started with React Navigation. And depending on the navigator that you use, you're going to be also installing specific navigators, which we'll see in the next section. By now, you know about the navigation libraries that you can install and configure for your React Native project. While there are several approaches you can take, let's focus on setting up one of the most common libraries, which is the Stack Navigator. Recall that Stack Navigator provides a way for your app to transition between screens, where each new screen is placed on top of a stack. In this video, you'll learn how to set up the Stack Navigator for your React Native app. This includes importing the elements that you'll need and defining the screens that will be in the stack. To be more specific, you'll be setting up Stack Navigator for the Little Lemon app. Currently, there are 2 screens, and users will need a way to move between them. Before you proceed with this video, note that there are a few prerequisites. First, make sure that you've installed the native Stack Navigator from React Navigation/stack. You'll also need to install React Native Gesture Handler if you haven't already done so. Once those dependencies are installed, you're ready to start adding Stack Navigation to your Little Lemon app. Here, within the Little Lemon app, I have 2 screens which I've defined. One is a welcome screen that displays the Little Lemon logo, along with some introductory text. Another is the menu screen, which displays the restaurant's menu items. Now, what I want to do is create a stack navigation methodology that allows the user to navigate between these 2 screens, and I'll do this by using the Stack Navigator. First things first, I need to import the navigation container. This is the component that I'll wrap the entire app into, and it comes from React Navigation/native. Because I'll be using Stack Navigator, I'll also need to import the Create Native Stack Navigator component from React Navigation/native stack. The next thing to import would be the screens themselves. So I'll import welcome screen from ./screens/welcome screen. Then I'll import menu screen from ./screens/menu screen. And that's it for the imports. My next task will be to instantiate the stack. Keep in mind that all the routes will be pushed on top of a stack. So I'll name the new instance stack and give it the Create Native Stack Navigator method. I'll use this stack object to create my Stack Navigator. Let's go over to the return statement of the application, where I'll call the navigation container component. Remember that this will wrap around the whole app, so all other components will be placed between the navigation container tags. Next, I'll need to call the stack that I just defined, along with its navigator prop, and wrap it around the rest of the app. So that's stack.navigator in the tag. Within the Stack Navigator, I'll call the Stack Screen component, and this is where I'll define the screens that belong to the stack. The first screen is the welcome screen, which I'll give the name Welcome, and then pass in the welcome screen component. So I would type this inside a tag as stack.screen, name equals, followed by welcome in quotes, component equals, and then welcome screen in curly braces. And don't forget to close the tag. In this manner, you can add as many screens to your stack navigation as you'd like. But in my case, I'll just add the other screen, which is the menu screen. So, to recap what I've done here, I've imported the Stack Navigator component, I've called the Create Native Stack Navigator function, and I've instantiated a stack. The entire app will then be wrapped within the navigation container and currently consists of two screens, which are the welcome screen and the menu screen. At this point, I've set up the bare minimum that is needed for stack navigation. I haven't set up a way to move between screens just yet, but you'll learn how to do that soon. For now, let's find out how this navigator appears on the emulator. So I start on the welcome screen, which has the little lemon logo and text as you've observed before. But notice that this time there is also a header at the top that reads Welcome. This comes from the name that I gave to the stack screen. Currently there is no way to get to the menu screen. However, the main pieces of the stack are in place and the stack is ready to be customized further. In this video, you learned how to set up Stack Navigator for a React Native app. This includes knowing which elements you need to import before starting and how to define the screens in the stack. To recap what I've already done up to this point for the Little Lemon app in terms of navigation, I've set up Stack Navigation and defined two screens for it, which are the welcome screen and the menu screen. You should know that React Navigation provides several options and props that you can pass to the navigator, as well as the screen to customize your navigation experience. So in this video, you'll learn about a few of these props and how to use them. First of all, let's say that I want to display a header name that is different from the name that has been given to the screen. For example, I want the header for the welcome screen to read Home rather than Welcome. Fortunately, I can do this with the Options prop. So I'll call the options in the stack screen for the welcome screen, and there I can simply assign the title Home in quotes. Now, whenever the welcome screen is displayed through the Stack Navigator, it reads Home in the header bar. I can also add options directly to the Stack Navigator. Why would this be useful? Well, let's say that I want to change the name of the initial route. By default, the first screen in the navigator determines the initial route. In this case, it's the welcome screen, but I want the menu screen to show first when the user opens the app. To change it, within the Stack Navigator tag, I'll type initial route name equals, followed by the word menu in quotes. And now the initial route is menu. Next, let's move on to customizing the appearance of the navigator. To do this, I can pass in the Screen Options prop. In my case, I want the header bar to have a different background color. To do that, I'll use the property header style, and in here I'll set background color to a new hexadecimal color value. Okay, I've made a few changes, so now let's review them in the emulator. To recap, I'm expecting to see a different initial route name, a different screen title, and a new color for the header bar. And there you go. The initial route is now menu, and the header bar color has changed. If you were to change the initial route name back to welcome, then the app would open on the welcome screen again. In there, you'd find that the title shown in the header bar reads Home rather than Welcome, since I defined it as such with the options prop. This is just a small sampling of the many customization options available for your navigator. If you'd like a more complete list of the props and options that you can use, I'd recommend checking out the documentation for React Navigation, which you'll find a link for in the additional resources. In this video, you learned how to use a few of the props of React Navigation. Specifically, you observed how to use options to change the header title for a screen, how to change the initial route of the navigator, and how to use screen options to apply a different background color for the header. So far, you've become familiar with the basics of React Navigation. You've learned how to set up the React Navigation library for your project, as well as how to configure and use the Stack Navigator. Keep in mind, however, that navigation between screens isn't a single path or direction, and users will need to be able to move forward, backward, and jump across a stack. In the Little Lemon app, let's say you've set up all the screens on the Stack Navigator, so now you're ready to give users the ability to move between these screens. Because users won't be accessing the screens in the same order, you'll need to set it up in a way that allows them to move back and forth without getting lost. That's why, in this video, you'll learn how and when to use several methods of the navigation prop to establish navigation rules. Recall that if you want users to navigate to a specific route or page on a web browser, you would write a line of HTML code. This code consists of an anchor tag and the route passed to the href. On screen, it will display the text between the tags. When the user clicks on the text, they will be sent to details.html. Now, how would you do this on mobile using React Navigation? You would do something similar, but instead you'll use the navigation prop. The navigation prop is passed to every screen component in the native Stack Navigator. There are several functions that you can call through the prop to set different behaviors. You'll become familiar with some key methods of the navigation prop. Specifically, you'll learn about the navigate, push, go back, and pop to top methods. Let's start with the navigate function. You call this along with the name of the route that you'd like the user to use. Going back to that web browser navigation example, let's observe how you could achieve the same thing in React Native using the navigate function. Consider this example code that consists of a button component titled GoToDetails and passes the navigation prop to the button's onPress prop. The navigate function is called when the user presses the button and they are sent to the details route. In this example, the destination route has a name that has already been defined in the Stack Navigator. But what happens if you call the navigate function with a route name that you have not defined? Well, it will print an error in the development builds and nothing will happen in the production builds. This will not crash the app or cause failures, but instead it will error out in your development mode. In addition to the navigate method, you can use another method called push. You call push whenever you want to add a new route to the navigation stack. Navigate and push might seem similar at first, but let's compare them. When you call navigate, it will first try to find an existing route with that name, and only pushes a new route if there isn't one on the stack yet. But with the push method, you will add another route on top of the stack, regardless of the navigation history. Next, let's discuss how to move back to the previous screen. One way you could do this is to simply use the header bar that is provided by the navigator, which will automatically include a back button. But another approach that involves code would be to use the go back method. Using the go back method will also take the user back to the previous screen in their navigation history. For example, this means that if a user's path went from screen 1 to screen 2 to screen 3 and finally to screen 4, then clicking a button that calls go back will send them back to screen 3. However, there are times when a user wants to jump back to the very first screen without having to go one screen at a time. How would you make this possible? Worry not, as React Navigation has a solution in the form of the pop-to-top method. This method allows the user to go back to the first screen instantly. That means that no matter what screens are in the user's navigation history, a button with pop-to-top can take the user from that screen back to screen 1 with a single action. So there you have it. There are several methods to customize the navigation prop in Stack Navigator to suit different user needs. In this video, you learned how to use navigate to send the user to a specific route, push to set up additional routes, go back to send the user to the previous screen, and pop to top to send them back to the first screen. You now have a better idea of how to improve the navigation experience, no matter what path the user takes. Nice work. So far, I've defined my Stack Navigator with a couple of stack screens, and I also provided some options for styling and so on. Now, all that's left to do is move between the two screens I defined in the stack. In this video, you'll learn how to set up a pressable component that allows users to move between the two screens in the Stack Navigator in the Little Lemon app. To do that, I go to the Welcome screen, and the first thing I'm going to do is add a property to the component named Navigation. Here, I've already set up the Stack Navigation, so when I pass this navigation prop to the Welcome screen, it already knows where it's coming from. Next, I import the pressable component because I want a pressable area that says View Menu. In other words, I'll have the pressable component, and inside of it there will be some text saying View Menu. For now, I close the text and the pressable tag. The next step is to add some styling to the View menu. I've already defined some styles, so I'm going to use that. It's called the button text style. Within the pressable component, I have the onPress method, which is going to call the callback handler. And this is where I'm going to use the navigation prop that was passed to this component. And I'm going to say navigation.navigate. And within the navigate method, I tell the navigator where to go. I want it to go to the menu screen. And that's it. I'm all set. Now, within the welcome screen component, there is the text that says View Menu. When I click on it, it takes me to the next screen, which is the menu screen. As long as the menu screen is defined within the Stack Navigator, then it will automatically take me to the new screen. Let's examine the emulator. All right, I have my little lemon app all loaded up. At the top, there is a header that says Home. That's what I've named the welcome screen. And there's some welcome text, as well as the View Menu pressable area. I'm going to go ahead and click on View Menu. And there you go. It navigates to the next screen, the menu screen, and you can note all the menu options. Also, notice that you get a back button, which I did not code for. Clicking on the back button takes me back to the previous screen, the home screen. You can go back and forth between them whenever you'd like. And that's how it's done. In this video, you have learned how to set up a pressable component for moving between screens in a stack. In this video, you'll learn how you can program a pressable component that the user interacts with to return to the previous screen in a navigation stack. This will be done with the go back method that is found in the navigation prop. In the Little Lemon app, let's move from the opening home screen to the menu screen by clicking on the View Menu button. Notice that the header bar provided by the native Stack Navigator automatically includes a back button that I can use to return to the previous screen. It's nice to have this by default, but you may also want to program this behavior yourself. For example, let's say that in addition to the back button, you want to place another button elsewhere on the screen that can serve the same purpose. So how can you do that with the Stack Navigator? Let's go back to the project code and find out. To add a new button in the menu screen, I first include the navigation prop in the menu screen component. I'll also use a pressable component, so I make sure to import that from React Native first. At the end of the section list that renders the menu, I add the pressable component and have it wrap some text that reads, Go back. I include the onPress function as the call handler, and I use the navigation prop and call the go back method. Now when the user clicks on the go back text, they will be taken to the previous screen of the stack. I also want to add some style to the text, so I use the pre-existing button text style from my style sheet. Now let's go back to the emulator to test out the new button. Again, I start on the home screen, so I click on View Menu to move to the menu screen. The back button is still in the header, but notice that at the very bottom there is also the text Go Back. This is a pressable area, so let's click on it. And there you go, I'm back to the previous screen. So once again, I go from the home screen to the menu screen and then back again by clicking on the Go Back text. So that was a demonstration in iOS, but let's switch over to an Android emulator this time. Note that there is some additional functionality here because the React navigation hooks into the back button that is built into the hardware, and it automatically fires the Go Back function. So what this means is if I click on View Menu to move to the menu screen, I actually have 3 ways to go back: the back button in the header, the Go Back text that I added as a pressable, and the Android device's hardware back button. I click on the hardware back button and sure enough, I'm back on the home screen. You also may have noticed that the transition animation between screens is different for both platforms. These transitions can be customized as needed to make for a better experience. In this video, you found out how to apply the Go Back method of the navigation prop to a pressable component, which allows the user to return to the previous screen. So far, I have set up my Stack Navigator. I have 2 screens on the stack, and I've also figured out how to navigate between the screens and how to go back to the previous screen. In this video, you are going to learn how to configure the header bar. Specifically, you'll style the header bar in the Little Lemon app and add an image on it. Keep in mind that I already have a header bar that comes with React navigation as soon as I have set up the Stack Navigator. In fact, I also gave my header bar a unique light pink background color within the screen options of the navigator under the header style. I now want to add more styling and clean up the header bar to look aesthetically more pleasing. In the screen options, I change the background color to a darker color by changing the hexadecimal value. I also give the header text tint a color. Now keep in mind that the tint of the header must be a lighter color because the background color is going to be darker and you need some contrast for easy reading. I add the header tint style. This is the style for the text that shows up on the header bar. I set the font weight to bold. I can also give font size and font family within the header tint style. And that is it for the header style. I've styled the screen options. I've given a background color for the header style, I've given a tint color for the text, and I've set the tint style to bold font weight. Now all of these are placed within the screen options of the navigator, which means it's applicable to both the welcome screen and the menu screen, and any other screens that are added within the stack. It is important to note that if I want unique styling per screen for the header bar, then I will have to add all of these options as options within the stack screen instead. To summarize, there are two ways to set styling. If you want the same style for all the screens, add the style to the screen options. If you want different styling for each screen, you have to add the style within the options of the stack screen. So how does the header style display on the emulator? On the iOS emulator, I now have a header bar that displays differently from what it previously displayed. The header bar has a darker grey color and the tint color is white with a bold font. By clicking on the View menu, I navigate to the next screen, which is the menu screen. On the new screen, the header bar displays the same new settings I have allocated to the style. This is because I've given it as a screen option within the navigator. In this manner, you can customize your header bar look and feel based on your requirements. Adrian wants me to add a logo to your header bar. Let me show you how to do that. Let's say I want to plug in a little image of the Little Lemon logo within my header bar instead of the welcome text. The first step is to import the image component because that's how I'm going to import the logo. Next, I create a new component called Logo Title, where the Little Lemon logo will be rendered. So within the return statement, I have an image and the source for this image, which is the image folder. So I'm going to add ./image/littlelemonsmalllogo.png, and then I close the image tag. I now add some styling to the image as I don't want to display the raw image as it is. In the style, I add a height of 40 pixels and a width of 300 pixels. To the resize mode, I give it the value of contain, and finally, I align this image to the center. The image component for the logo is ready, and all it does is render this image. What I want to do next is to render the logo title instead of welcome as a title for the header bar. So how do I do that? The first step would be to go to the stack screen for the welcome screen. Inside the options, I have given the title as home. In the options, I'm going to define another property called the header title. This can be used to render a certain component instead of the text for the header. So within the header title, it can take in as many props as needed. And here, I render the logo title and also pass in the props if there are any props. That's it. All I did was plug in the header title prop. I add a return function that is going to return the logo title component. So what this means is when the welcome screen displays on top of the header bar, within the header bar, the Little Lemon logo will display instead of any text. Now the same thing can be done for the other screens as well. This will not impact the other screens because this is an option that I've given specifically for this screen. How does this now display on the emulator? The Little Lemon logo now displays on the welcome page in the header bar. In other words, the logo displays instead of the name of this page, which was Welcome. When I click on the View menu, I navigate to the next page. On this page, the header bar still displays Menu and no logo appears. That is exactly what I expected, because I only designed the logo to display on the welcome page. If I go back to the welcome page, the Little Lemon logo is still there. This is the way you can configure your header bar to display whatever you like. It could be an icon image, and it could be some image and text. That is your decision. In this video, you have learned how to configure a header bar. So far, you have become familiar with how to set up navigation by using the Stack Navigator in the Little Lemon app to move between screens. Adrian wants you to explore different options with navigation for his app. He has heard about tab navigation and would like you to implement a tab navigation mechanism for his Little Lemon app. In this video, you will learn about tab navigation using React Navigation. This is an optional package of the React Navigation library that enables you to create tab-based navigation for moving between screens. There are different ways to navigate between one screen to another in mobile apps. The most common methodology is stack navigation, which you have encountered before, and then tab navigation, which I am going to address in this video. Do you remember the details around stack navigation? Let me refresh your memory with a quick summary. This Stack Navigator can transition between screens and manage the navigation history. You would need this navigation history when the user decides to go back to the previous screens. Right. Now, how does tab navigation differ from stack navigation? With this method, you can contain tabs on the bottom of the screen or on the header. Clicking on a tab takes you to a specific screen. This is a common design that you will see in modern mobile apps. React Navigation provides several options for tab navigation. It has an API for creating bottom tab navigation, material design-based bottom tab navigation, and material design-based top tab navigation. Bottom tab navigation allows you to switch between navigation routes bound to each tab, while the material design-based options expand upon this with more refined animation possibilities. You can pick up a navigator that fits your use case and design the needs accordingly. In this video, you will focus on learning bottom tab navigation with an example. Now, how does a typical tab navigation display on a screen? In the Little Lemon app, there are two tabs, one for the welcome screen and the other for the settings screen. The tabs are on the bottom with a different icon added for each tab. Clicking on the left-hand side tab will take navigate to the welcome screen, or clicking on the right-hand side tab will navigate to the settings screen. Now let's examine the code that you might use to create this two-tab setup. To set up the tab navigation for your mobile app, make sure to import the navigation container and the Create Bottom Tab Navigator from React Navigation. Once the navigators are imported, instantiate the tab using the Create Bottom Tab Navigator from React Navigation. Then, within your root app component, wrap the tab navigator within all the tab screens. Initialize all the screens that you can navigate to via the tabs. As previously said, in this example there are two screens, the welcome screen and the settings screen. Within the tab screen, ensure to provide a name for the tab. The tab name is usually displayed on the top of the screen. To the component prop, simply provide the component name, and you are all set. This is the minimal setup that you need to create tab navigation using React Navigation. A great function is that you can easily customize the appearance of the tabs, similar to how you have customized a stack navigator. Within the tab navigator, screen options such as icons, active and inactive tint colors are readily available. You will learn about these options later in the course. You'll be happy to know that React Navigation's tab navigator can also handle a lot of heavy lifting for you. For example, let's say you want your app to respond to the hardware back button on an Android device. With custom tab components, it typically takes multiple steps to do this, such as writing the logic and using a hook to access the native API. With Tab Navigator, however, this functionality is built right in. And that's not all. It's also easier to code tab navigations using React Navigation, since double tapping the tab bar will make the active navigation stack pop to the top of the stack. This is done automatically without any additional code from you. Please take note that if you were to use a standalone tab bar component, you will not get any of the actions that come for free with React Navigation. In this video, you have been introduced to tab navigation. You are now ready to implement tab navigation and code using the Tab Navigator to navigate between screens in the Little Lemon app. Adrian will be very happy. In this video, I'm going to integrate the tab navigation within the Little Lemon application. I have two screens in the project structure. One is the menu screen, where I just display this list of items for the Little Lemon menu using the section list component. I also have a welcome screen component that says Little Lemon, your local Mediterranean bistro, and it also displays a Little Lemon logo. Now, I want to design navigation between these two screens in the form of a tab navigation at the bottom of the screen. To do that, I get into the App folder. I must ensure that I have installed React Navigation /bottom tabs. Within your app file, make sure to import all the necessary components. I need to use the navigation container just like I used it in the stack navigation. This is the component that I'll use to wrap the entire app around. The component comes from the React Navigation /native folder. Next, I import the Create Bottom Tab Navigator. This comes from the React-Navigation /bottom tabs library. The next action to take is to import the two screens that are part of this application. One is the welcome screen. The next item is the menu screen. I now have to instantiate the tab. To do that, I directly declare the const tab. You can name it what you like. I am calling it tab. You can instantiate the tab using the Create Bottom Tab Navigator function. This is going to instantiate the tab, and I can now utilize that within my app. So now, inside the return statement, I add the navigation container, and the entire app is going to be wrapped around this navigation container. The next thing I do is to use the tab navigator. I'll make sure to set both the opening and closing tags in the tab navigator. And within this tab navigator is where I am going to do the tab screens and declare them. You can have as many screens as you'd like. So I'm going to have tab.screen, and the name I'm giving is welcome. I'm also giving a component name for it, which in this case is basically the welcome screen. And that would be the end of the tab screen. Similarly, the next tab screen is the menu screen. I name the tab screen menu, and the component that I pass it to is the menu screen component. So the app component is ready. All I did is have the navigation container wrap around the entire app. I also have tab navigators. Within that, I'm declaring the tab screens with the name and passing the components to it. Let's check out our updates in the emulator. On the emulator, the screen displays a welcome screen, the Little Lemon logo, and some welcome text. On the bottom of the screen, the welcome and menu tabs display as well. If I click on the menu tab, the menu screen displays, and I can scroll down in the menu, which lists all the available options. In this video, you've learned how to implement tab navigation into your Little Lemon app, specifically with a bottom tab navigator. This includes importing the necessary components, defining the screens to be included in the navigator, and moving between the screens via the tab on the bottom. So far, you have become familiar with how to set up navigation by using the Stack Navigator and the Tab Navigator to move between screens in the Little Lemon app. Adrian wants you to explore one more option for navigating in his app. He has read about drawer navigation and would like you to also implement a drawer navigation mechanism for his Little Lemon app. In this video, you will learn about drawer navigation using React Navigation. The drawer appears when the user touches the hamburger icon in the app bar or when the user swipes a finger from the edge of the screen. Drawer navigation is, like tab navigation, a common navigation pattern. It uses a drawer from left to right side for navigating between screens. You would use this pattern typically when there are many screens to navigate to. React Navigation provides drawer navigation, and the code to set it up is very similar to the other navigators, like Stack and Tab. In the Little Lemon app, there are two designed screens, one for the welcome screen and the other for the settings screen. You can swipe right to open the drawer and see the list of screens you can navigate to. Clicking on the welcome screen name from the drawer will take you to the welcome screen, and clicking on the settings screen name from the drawer will take you to the settings screen. Now let's examine the code that you might use to create this drawer navigation. To set up the drawer navigation for your mobile app, make sure to import the navigation container and the Create Drawer Navigator from React Navigation. Once the navigators are imported, you would instantiate the drawer using the Create Drawer Navigator from React Navigation. Then, within your root app component, you will wrap the drawer navigator within all the drawer screens. You will initialize all the screens that you can navigate to via the drawer. As previously said, in this example there are two screens, the welcome screen and the settings screen. Within the drawer screen component, make sure to provide a name for each drawer screen. This is usually displayed on the top of the screen. And to the component prop, simply provide the component name. This is the minimal setup that you need to create drawer navigation using React Navigation. So how will this display on the emulator? Notice that the drawer displays a hamburger menu on the top left corner of the screen. This can be clicked and it will open the drawer right away. This is applicable to both Android and iOS platforms. You can either swipe to open the drawer or simply click on the hamburger menu. You can also customize the drawer position. By default, you swipe to your right and the drawer opens on the left. You can add an option to the drawer navigator to open the drawer on the right with a left swipe as well. That's not all. You can also customize your app to support multiple drawers, one on the right and one on the left. Isn't that neat? In this video, you have been introduced to drawer navigation to move between screens on the mobile app by swiping to the left or right on the screen. You are now ready to try some code using the drawer navigator to navigate between screens in the Little Lemon app. In this video, you are going to learn how you can use drawer navigation within the Little Lemon app. So far, you've been familiarized with stack navigation and with tab navigation. In this example, you'll find out how to use the drawer navigation method to navigate to the welcome screen and the menu screen. Now, drawer navigation can be done from left to right or from right to left. You will discover a bit later what happens by default. The first thing I need to do is to make sure that I import the right files and libraries. Before you start, make sure that you've installed React Navigation/drawer. If you haven't, make sure you use npm or yarn and install that first. The next step will be to import the navigation container. Keep in mind that this is the same container that I've used for all the React navigation to date, and I'll be using it again for drawer navigation. Next, I import the Create Drawer Navigator from React Navigation. You will find this in React Navigation as well, but under the name React Navigation/drawer. This is all I need at this moment, and now I'm ready to build my drawer navigator. Now, the first thing I have to do is to instantiate the drawer. To do that, I'll take a const and I call it drawer. You can give it any name you like, and I name it Create Drawer Navigator. I now set the navigation container and wrap everything under the container. This time I use the drawer navigator and I make sure I close that tab. This is where I am going to do the drawer screen. As always, I must ensure to give a name to the screen. I call it the welcome screen. The component I am going to use is the welcome screen component. I also need to ensure that I import the welcome screen and the menu screen components. I import the welcome screen from the screens folder where I've stored it, and then I do the same for the menu screen. Perfect. Because I can build the menu screen within the drawer navigator in a similar manner to the welcome screen, I'll just copy and paste the drawer.screen line. This time I call that screen as the menu screen and I pass through the menu screen component. Before I can proceed to the emulator, I need to make sure that I add one last prop to the navigator. It's called the Use Legacy implementation. This is a step that is recommended by React Navigation when working with drawer navigation in order to get a more consistent performance. For this version of React Navigation, I use the prop Use Legacy implementation for the drawer to work. How does this display on the iOS emulator? On the welcome screen, there are two ways to open the drawer. The first is by clicking on the hamburger menu to open the drawer. The welcome and the menu navigation options are available. Now, if I click or tap on the menu options are displayed. So clicking has taken me to a different screen. I can also swipe from left to right on the screen to open the drawer. This is the default way the drawer works. I can, however, tweak this behavior to move the drawer to the right side of the screen. Let me go back to the code and note how I make this change. I add a screen option to the drawer navigator, the property drawer position, and by default, this is left. So I'm going to change that to right, and that's it. So all I did was simply add a screen option and give it a draw position of right. Let's check out these updates in the emulator. When I click on the hamburger icon, the drawer now opens on the right side of the screen. So you can always tweak your drawer navigation to either open on the left or right by giving that screen option. If I click on the menu options display again. And this time, if you want to swipe to open, make sure that you're pulling from right to left and you'll be able to display the drawer again. You have now learned how you can use drawer navigation within the Little Lemon app. Go and try it out. Remember, practice makes perfect. Well done! You've reached the end of the React Navigation module. Let's take a few moments to review what you learned during this module. You began with a module introduction in which you were exposed to the basic concepts of React Navigation. Now that you've completed this module, you can describe what React Navigation is, explain how React Navigation can be used to transition between screens in React Native, and describe the benefits and trade-offs of using React Navigation. You should also know how to install and set up React Navigation in React Native, and create and configure the native Stack Navigator. You were then given a demonstration on how to apply the Stack Navigator to the Little Lemon app. During this process, you found out how to build a Stack Navigator consisting of 2 screens, customize screens by passing in props, and set up navigation routes. You then moved on to the next lesson, in which you were familiarized with moving between screens. In this lesson, you explored some methods of the navigation prop for customizing behavior. This includes designating routes with the navigate method, adding new routes with the push method, enabling backward navigation with go back, and sending the user to the top of the stack with pop to top. You also learned how to write the code to navigate between screens in a stack, go back to a previous screen, and configure and customize a header bar. You then undertook the next lesson in this module, in which you learned about tab navigation. Following this lesson, you should now be able to explain what tab navigation is and how it differs from stack navigation, and describe how to apply and configure a tab navigator in a React Native app. You also became familiar with how to create code for tab navigation in React Navigation and customize your tab navigator. In the final lesson of the module, you shifted your attention to drawer navigation. You should now be able to explain what drawer navigation is and how it differs from stack navigation and tab navigation, and describe how to apply and configure a drawer navigator in a React Native app. You're now familiar with the basics of React Navigation, and you've done some coding exercises. You can now incorporate these navigation tools within your app. Enjoy! Well done on completing this course on React Native. In this course, you learned about the basics of working with React Native. You applied these skills toward building a mobile app for the restaurant Little Lemon, which allows users to do things like view a menu and fill out a feedback form. Let's take a few moments to recap the knowledge you gained to bring this app to life. You started off by learning about what React Native is, its benefits and use cases. You then learned about the basic components in React Native, styling the components, and using them to build a React Native app. Next, you moved on to the core components of React Native, such as view, text, and scroll view. These primarily concern setting up the visual layout of your app. In the next module, you learned about the rendering of large lists within your mobile app and inputting text via the keyboard. You have learned how to build large and performant lists with both flat list and section list components. And you also learned how to configure user inputs via keyboard using the text input component. The next module was about creating pressable components, rendering images, and using React Native hooks. This included learning to build buttons and other pressable areas to add interactivity to your apps. You also learned how to display and style images in an app. You became familiar with some common React Native hooks, which can extend the functionality of your React components. In the module that followed, you learned about navigating between screens using React Native navigation. You have learned about different types of navigation, such as stack, tab, and drawer navigation, which are widely used in mobile apps. You also became familiar with the core features of React navigation. And by the end of this module, you were able to set up your app with React navigation and move between screens. The final part of the course will focus on the graded assessment. For this assessment, you will create a Little Lemon newsletter sign-up form in React Native. You'll also get an opportunity to review your classmates' projects, since this is a peer-graded assignment. There were many videos in the course that gradually guided you toward your goal of becoming a developer. You had the opportunity to watch, pause, rewind, and rewatch the videos until you were confident in your skills. Then you consolidated your knowledge by consulting the course readings and putting your skills into practice during the course exercises. Along the way, you have encountered several knowledge quizzes where you could self-check your progress. There were course discussion prompts that helped you to connect with your classmates. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. You've reached the end of this course on React Native. Congratulations. Take a moment to reflect on how far you've come. When you started, you were just getting to know about the benefits of React Native for cross-platform development. And now, you already know how to build an app that allows users to scroll, enter text, move between screens, and more. You also applied your knowledge by completing a lab project. This project had you build a newsletter sign-up form using React Native. Your form should make use of some common core components of React Native, including view and text, text input, image, and pressable or button. Your form should demonstrate your ability to use React navigation to enable users to move between screens, configure a pressable or button component to respond to user actions, and configure a context-sensitive text input component. Perhaps most importantly, completing this lab gave you experience with an important and transferable set of skills that you will be able to apply to many of your future React Native apps. So, what comes next? Well, if you'd like to further your knowledge, then the React Advanced course is probably the best next step in your journey. And once you've successfully completed all the courses in this program, you'll receive a certificate that you can use to validate your achievements. It also sets a pathway for progression to other meta role-based certificates. Depending on your goals, you may choose to explore specific roles more thoroughly or enroll in other fundamental courses. Meta certificates provide globally recognized evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.